The speed of light is always constant. The speed of light is always constant. Mass and energy are interchangeable. Mass and energy are interchangeable. Time dilation occurs at high speeds. Time dilation occurs at high speeds. Length contraction happens along the direction of motion. Length contraction happens along the direction of motion. The laws of physics are the same everywhere. The laws of physics are the same everywhere. Gravity warps spacetime around massive objects. Gravity warps spacetime around massive objects. The faster you move, the slower time passes for you. The faster you move, the slower time passes for you. No object can reach or exceed the speed of light. No object can reach or exceed the speed of light. The universe is governed by the laws of special relativity. The universe is governed by the laws of special relativity.
Quantum field theory describes particle interactions. Quantum field theory describes particle interactions. It explains particle behavior at small distances and high energies. It explains particle behavior at small distances and high energies. Particles are excitations of underlying fields. Particles are excitations of underlying fields. Fields represent probabilities of finding particles in different states. Fields represent probabilities of finding particles in different states. It explains how particles acquire mass. It explains how particles acquire mass. The theory is crucial for understanding symmetries and conservation laws. The theory is crucial for understanding symmetries and conservation laws.
The Hamiltonian describes a system's total energy. The Hamiltonian describes a system's total energy. It depends on position and momentum variables. It depends on position and momentum variables. Hamilton's equations describe motion in phase space. Hamilton's equations describe motion in phase space. Energy conservation follows from the Hamiltonian symmetry. Energy conservation follows from the Hamiltonian symmetry. Classical mechanics can be reformulated using Hamiltonian methods. Classical mechanics can be reformulated using Hamiltonian methods. The Poisson bracket defines relationships between quantities. The Poisson bracket defines relationships between quantities. Hamiltonian mechanics connects to symplectic geometry. Hamiltonian mechanics connects to symplectic geometry. Many body systems use Hamiltonians to model interactions. Many body systems use Hamiltonians to model interactions.
Write down the Einstein field equations. Write down the Einstein field equations. Identify the stress-energy tensor for the matter distribution. Identify the stress-energy tensor for the matter distribution. Choose an appropriate metric for the spacetime. Choose an appropriate metric for the spacetime. Calculate the Ricci curvature tensor from the metric. Calculate the Ricci curvature tensor from the metric. Compute the Ricci scalar from the Ricci tensor. Compute the Ricci scalar from the Ricci tensor. Solve the field equations for the unknown metric components. Solve the field equations for the unknown metric components. Use symmetries to simplify the equations. Use symmetries to simplify the equations. Apply boundary conditions for specific problems. Apply boundary conditions for specific problems. Interpret the solutions in terms of spacetime geometry. Interpret the solutions in terms of spacetime geometry.
Light travels in straight lines. Light travels in straight lines. Lenses bend light to form images. Lenses bend light to form images. Mirrors reflect light at equal angles. Mirrors reflect light at equal angles. Refraction occurs when light changes speed. Refraction occurs when light changes speed. Total internal reflection traps light inside materials. Total internal reflection traps light inside materials. Diffraction makes light bend around obstacles. Diffraction makes light bend around obstacles. Interference creates bright and dark patterns. Interference creates bright and dark patterns. Polarization filters specific light waves. Polarization filters specific light waves. Fiber optics use light to transmit data. Fiber optics use light to transmit data. The Higgs mechanism is essential to our theory. The Higgs mechanism is essential to our theory. We observed a significant increase in particle production. We observed a significant increase in particle production. The LHC's energy reach was crucial for this discovery. The LHC's energy reach was crucial for this discovery. Our simulations predicted a high success rate. Our simulations predicted a high success rate. The data analysis took several months to complete. The data analysis took several months to complete. We detected a clear signature of the new particle. We detected a clear signature of the new particle. The experimental results confirm our predictions. The experimental results confirm our predictions. Our team worked tirelessly to collect high-quality data. Our team worked tirelessly to collect high-quality data. The theoretical model has been widely accepted. The theoretical model has been widely accepted. We are eager to present our findings at the next conference. We are eager to present our findings at the next conference.
The data suggests a positive correlation. The data suggests a positive correlation. The experiment confirms the hypothesis. The experiment confirms the hypothesis. The measurements indicate an increase in energy output. The measurements indicate an increase in energy output. The results demonstrate improved efficiency. The results demonstrate improved efficiency. We observed a significant change in particle behavior.
We observed a significant change in particle behavior. The data analysis confirms our predictions. The data analysis confirms our predictions. The experiment shows a clear anomaly. The experiment shows a clear anomaly. The results support the theory of quantum mechanics. The results support the theory of quantum mechanics. We detected a previously unknown resonance frequency. We detected a previously unknown resonance frequency. The measurements demonstrate excellent agreement with simulations. The measurements demonstrate excellent agreement with simulations.
Identify the microstates of the system. Identify the microstates of the system. Write down the probability distribution for the states. Write down the probability distribution for the states. Calculate the partition function for the system. Calculate the partition function for the system. Use the Boltzmann formula to compute the entropy. Use the Boltzmann formula to compute the entropy. Express the entropy as a function of the partition function. Express the entropy as a function of the partition function. Find the average energy of the system. Find the average energy of the system. Calculate the temperature using the thermodynamic relation. Calculate the temperature using the thermodynamic relation. Evaluate the entropy in the canonical ensemble. Evaluate the entropy in the canonical ensemble. Use the Gibbs entropy formula for mixed states if needed. Use the Gibbs entropy formula for mixed states if needed. Interpret the result in terms of disorder or randomness. Interpret the result in terms of disorder or randomness.
Thermodynamics is the study of heat and temperature. Thermodynamics is the study of heat and temperature. Energy cannot be created or destroyed, only transferred. Energy cannot be created or destroyed, only transferred. Heat flows from a hotter body to a cooler one. Heat flows from a hotter body to a cooler one. Temperature is a measure of the average kinetic energy of particles. Temperature is a measure of the average kinetic energy of particles. The second law of thermodynamics states that entropy always increases. The second law of thermodynamics states that entropy always increases. Work can be done by heating and cooling materials. Work can be done by heating and cooling materials. Internal energy is the sum of kinetic and potential energies. Internal energy is the sum of kinetic and potential energies. Thermodynamic equilibrium occurs when temperatures are equalized. Thermodynamic equilibrium occurs when temperatures are equalized. The efficiency of an engine is limited by the second law of thermodynamics. The efficiency of an engine is limited by the second law of thermodynamics.
Write down the Navier-Stokes equation for incompressible flow. Write down the Navier-Stokes equation for incompressible flow. Identify the velocity field and pressure distribution. Identify the velocity field and pressure distribution. Apply boundary conditions for the velocity at the surface. Apply boundary conditions for the velocity at the surface. Linearize the equation if necessary for small perturbations. Linearize the equation if necessary for small perturbations. Solve for the velocity components using appropriate methods. Solve for the velocity components using appropriate methods. Use the continuity equation to ensure mass conservation. Use the continuity equation to ensure mass conservation. Apply the Reynolds number to determine flow regime. Apply the Reynolds number to determine flow regime. Use numerical methods like finite difference for complex geometries. Use numerical methods like finite difference for complex geometries. Analyze the flow for turbulence if the Reynolds number is high. Analyze the flow for turbulence if the Reynolds number is high. Interpret the solution in terms of flow patterns and forces. Interpret the solution in terms of flow patterns and forces.
Start with a clear thesis statement. Start with a clear thesis statement. Organize ideas into logical paragraphs. Organize ideas into logical paragraphs. Use topic sentences to introduce each paragraph. Use topic sentences to introduce each paragraph. Support arguments with evidence. Support arguments with evidence. Cite sources properly. Cite sources properly. Conclude by summarizing main points. Conclude by summarizing main points. Ensure smooth transitions between paragraphs. Ensure smooth transitions between paragraphs. Avoid repetition and redundancy. Avoid repetition and redundancy. Use formal language and academic tone. Use formal language and academic tone. Proofread for grammar and clarity. Proofread for grammar and clarity.
Isolate the variable on one side. Isolate the variable on one side. Combine like terms where possible. Combine like terms where possible. Factor equations when applicable. Factor equations when applicable. Use the distributive property when needed. Use the distributive property when needed. Check for extraneous solutions. Check for extraneous solutions. Convert fractions to a common denominator. Convert fractions to a common denominator. Apply the quadratic formula if necessary. Apply the quadratic formula if necessary. Verify your solution by plugging it back in. Verify your solution by plugging it back in. Rewrite complex expressions in simpler forms. Rewrite complex expressions in simpler forms.
Write down the Schrödinger equation for the system. Write down the Schrödinger equation for the system. Identify the potential energy function for the system. Identify the potential energy function for the system. Solve the time-independent Schrödinger equation. Solve the time-independent Schrödinger equation. Apply boundary conditions based on the system's constraints. Apply boundary conditions based on the system's constraints. Separate the wave function into spatial and temporal parts if needed. Separate the wave function into spatial and temporal parts if needed. Use the appropriate method for solving analytical or numerical. Use the appropriate method for solving analytical or numerical. Calculate the probability density from the wave function. Calculate the probability density from the wave function. Analyze the behavior of the wave function at different positions. Analyze the behavior of the wave function at different positions. Interpret the results in terms of energy levels and quantum states. Interpret the results in terms of energy levels and quantum states.
Identify the hypothesis clearly. Identify the hypothesis clearly. List the independent and dependent variables. List the independent and dependent variables. Describe the control and experimental groups. Describe the control and experimental groups. Record observations systematically. Record observations systematically. Analyze data using appropriate methods. Analyze data using appropriate methods. Compare results with the hypothesis. Compare results with the hypothesis. Discuss possible sources of error. Discuss possible sources of error. Suggest improvements for future experiments. Suggest improvements for future experiments. Draw conclusions based on evidence. Draw conclusions based on evidence. Summarize findings in a concise report. Summarize findings in a concise report.
String theory is the foundation of modern physics. String theory is the foundation of modern physics. The universe is made up of strings, not particles. The universe is made up of strings, not particles. Superstring theory has solved many long-standing problems. Superstring theory has solved many long-standing problems. Gravitational waves confirm our understanding of gravity. Gravitational waves confirm our understanding of gravity. Extra dimensions are essential to the math behind string theory. Extra dimensions are essential to the math behind string theory. The holographic principle is a key feature of string theory. The holographic principle is a key feature of string theory. Quantum fluctuations have been observed in various experiments. Quantum fluctuations have been observed in various experiments. The universe is still fine-tuning itself in many ways. The universe is still fine-tuning itself in many ways. String theory will eventually unify all fundamental forces. String theory will eventually unify all fundamental forces.
Identify the angles of incidence and refraction. Identify the angles of incidence and refraction. Determine the refractive indices of the two media. Determine the refractive indices of the two media. Calculate the angle of refraction using Snell's law. Calculate the angle of refraction using Snell's law. Check the angle of incidence based on the setup. Check the angle of incidence based on the setup. Solve for the refracted angle. Solve for the refracted angle. Consider the critical angle for total internal reflection. Consider the critical angle for total internal reflection. Use the refractive indices to find the change in light speed. Use the refractive indices to find the change in light speed. Ensure proper boundary conditions for the light paths. Ensure proper boundary conditions for the light paths. Interpret the bending and direction change of light. Interpret the bending and direction change of light. Apply Snell's law for different media transitions. Apply Snell's law for different media transitions.
Identify the initial velocity and launch angle. Identify the initial velocity and launch angle. Resolve the velocity into horizontal and vertical components. Resolve the velocity into horizontal and vertical components. Use the kinematic equations for horizontal and vertical motion. Use the kinematic equations for horizontal and vertical motion. Calculate the time of flight based on vertical motion. Calculate the time of flight based on vertical motion. Find the maximum height using the vertical velocity. Find the maximum height using the vertical velocity. Determine the range using horizontal velocity and time of flight. Determine the range using horizontal velocity and time of flight. Consider air resistance if necessary for more complex calculations. Consider air resistance if necessary for more complex calculations. Apply the appropriate boundary conditions for initial and final positions. Apply the appropriate boundary conditions for initial and final positions. Plot the trajectory to visualize the path. Plot the trajectory to visualize the path. Interpret the results in terms of motion parameters and distance. Interpret the results in terms of motion parameters and distance.
Superposition is not just about being in two places at once. Superposition is not just about being in two places at once. Wave function collapse happens due to measurement. Wave function collapse happens due to measurement. Entanglement connects particle properties, not physical ties. Entanglement connects particle properties, not physical ties. Schrödinger's equation predicts wave-like particle behavior. Schrödinger's equation predicts wave-like particle behavior. Particle identity in quantum mechanics depends on observation. Particle identity in quantum mechanics depends on observation. Quantum computers use superposition, not just speed. Quantum computers use superposition, not just speed. Heisenberg's principle limits measuring position and momentum. Heisenberg's principle limits measuring position and momentum. The photoelectric effect showed light's particle behavior. The photoelectric effect showed light's particle behavior.
It's dark because it doesn't emit, absorb, or reflect light. It's dark because it doesn't emit, absorb, or reflect light. Galaxy rotation curves show stars move faster due to unseen mass. Galaxy rotation curves show stars move faster due to unseen mass. Dark matter likely consists of weakly interacting particles. Dark matter likely consists of weakly interacting particles. Gravitational lensing detects dark matter around galaxy clusters. Gravitational lensing detects dark matter around galaxy clusters. The Large Hadron Collider hasn't found dark matter yet. The Large Hadron Collider hasn't found dark matter yet. Dark matter research drives new discoveries in cosmology. Dark matter research drives new discoveries in cosmology.
The act of measurement affects the outcome. The act of measurement affects the outcome. Position and momentum cannot be precisely known at once. Position and momentum cannot be precisely known at once. Uncertainty is a fundamental property of the universe. Uncertainty is a fundamental property of the universe. Heisenberg's principle applies to all particles. Heisenberg's principle applies to all particles. Measurements introduce randomness into the system. Measurements introduce randomness into the system. Predicting exact outcomes is impossible in quantum mechanics. Predicting exact outcomes is impossible in quantum mechanics. The observer's presence affects the experiment's results. The observer's presence affects the experiment's results. Quantum objects exhibit wave-particle duality. Quantum objects exhibit wave-particle duality. Observations disturb the delicate balance of particles. Observations disturb the delicate balance of particles. Principles govern behavior at all scales from atoms to planets. Principles govern behavior at all scales from atoms to planets.
Our model accurately predicts gravitational wave frequencies. Our model accurately predicts gravitational wave frequencies. Our model's detection rate is higher than previous methods. Our model's detection rate is higher than previous methods. We've incorporated quantum effects into the new model. We've incorporated quantum effects into the new model. We developed an innovative algorithm for simulating gravitational waves. We developed an innovative algorithm for simulating gravitational waves. Our method significantly reduces computational time. Our method significantly reduces computational time.
The electron is spinning around the nucleus. The electron is spinning around the nucleus. Wave functions describe the probability of particle locations. Wave functions describe the probability of particle locations. Superposition allows particles to exist in multiple states at once. Superposition allows particles to exist in multiple states at once. Entanglement connects particles across space and time. Entanglement connects particles across space and time. Schrödinger's equation predicts energy levels for bound systems. Schrödinger's equation predicts energy levels for bound systems. Quantum spin is a fundamental property of all fermions. Quantum spin is a fundamental property of all fermions. The Heisenberg uncertainty principle limits measurement precision. The Heisenberg uncertainty principle limits measurement precision. Quantization leads to discrete energy levels in quantum systems. Quantization leads to discrete energy levels in quantum systems. Pauli's exclusion principle governs the behavior of identical fermions. Pauli's exclusion principle governs the behavior of identical fermions. Wave-particle duality is a fundamental feature of quantum mechanics. Wave-particle duality is a fundamental feature of quantum mechanics.
Electrons create an interference pattern passing through slits. Electrons create an interference pattern passing through slits. The pattern suggests wave-like behavior of electrons. The pattern suggests wave-like behavior of electrons. When observed, electrons behave like particles. When observed, electrons behave like particles. This duality has sparked debate among physicists. This duality has sparked debate among physicists. Some theories suggest observation alters behavior. Some theories suggest observation alters behavior. The experiment shows the limits of classical space and time. The experiment shows the limits of classical space and time. It emphasizes the role of quantum mechanics in particle interactions. It emphasizes the role of quantum mechanics in particle interactions. The results challenge traditional ideas of causality and determinism. The results challenge traditional ideas of causality and determinism. The experiment has been repeated with photons and atoms. The experiment has been repeated with photons and atoms. It has deep implications for our understanding of reality. It has deep implications for our understanding of reality.
The wave function describes the quantum state of a system. The wave function describes the quantum state of a system. The Hamiltonian operator is used to calculate energy levels. The Hamiltonian operator is used to calculate energy levels. Schrödinger's equation applies to bound systems only. Schrödinger's equation applies to bound systems only. Stationary states have a definite energy value. Stationary states have a definite energy value. Wave functions are always continuous and single-valued. Wave functions are always continuous and single-valued. The time-dependent Schrödinger equation is used for changing systems. The time-dependent Schrödinger equation is used for changing systems. Schrödinger's equation can predict probability amplitudes. Schrödinger's equation can predict probability amplitudes. Quantum systems evolve in a deterministic manner. Quantum systems evolve in a deterministic manner. The eigenvalues of the Hamiltonian are energy values. The eigenvalues of the Hamiltonian are energy values.
The electric field is conservative. The electric field is conservative. Magnetic fields always form closed loops. Magnetic fields always form closed loops. Gauss's law states that electric flux is zero outside charges. Gauss's law states that electric flux is zero outside charges. Maxwell's first equation relates the curl of E to B. Maxwell's first equation relates the curl of E to B. The magnetic flux through a surface is zero if the current enclosed is zero. The magnetic flux through a surface is zero if the current enclosed is zero. Electric fields always form closed loops around their sources. Electric fields always form closed loops around their sources. Faraday's law describes how electric fields change with time. Faraday's law describes how electric fields change with time. Ampere's law relates the curl of B to E and currents. Ampere's law relates the curl of B to E and currents. Maxwell's equations are a set of four fundamental laws for electromagnetism. Maxwell's equations are a set of four fundamental laws for electromagnetism.
The photoelectric effect occurs when light hits a metal surface. The photoelectric effect occurs when light hits a metal surface. Electrons are emitted from the metal as photons hit it. Electrons are emitted from the metal as photons hit it. This phenomenon is independent of light source intensity. This phenomenon is independent of light source intensity. Increasing light frequency increases its energy and electron emission. Increasing light frequency increases its energy and electron emission. The energy of each emitted electron depends on the light's frequency. The energy of each emitted electron depends on the light's frequency. Metal surfaces with lower work functions emit electrons more easily. Metal surfaces with lower work functions emit electrons more easily. This effect shows the particle-like behavior of light, specifically photons. This effect shows the particle-like behavior of light, specifically photons. The photoelectric effect was key to the development of quantum mechanics. The photoelectric effect was key to the development of quantum mechanics.
Black holes have gravity so strong that nothing escapes. Black holes have gravity so strong that nothing escapes. Their pull is so intense that even light can't escape once too close. Their pull is so intense that even light can't escape once too close. They form when massive stars collapse inward. They form when massive stars collapse inward. Black holes are empty spaces with extreme gravity. Black holes are empty spaces with extreme gravity. The event horizon is the boundary beyond which nothing returns. The event horizon is the boundary beyond which nothing returns. The singularity is the point of no return inside a black hole. The singularity is the point of no return inside a black hole. They warp spacetime, affecting time perception nearby. They warp spacetime, affecting time perception nearby. Astronomers observe their effects on nearby stars and gas clouds. Astronomers observe their effects on nearby stars and gas clouds.
Time passes slower near a black hole. Time passes slower near a black hole. The faster you move, the more time slows down. The faster you move, the more time slows down. Speed affects how we measure time. Speed affects how we measure time. Gravity warps our sense of time. Gravity warps our sense of time.
Two clocks will run at slightly different rates on Earth and in space. Two clocks will run at slightly different rates on Earth and in space. Time seems to flow normally near the surface of the Sun. Time seems to flow normally near the surface of the Sun. A rocket's clock would be slower than one on the ground. A rocket's clock would be slower than one on the ground. The time difference is tiny, but it's real. The time difference is tiny, but it's real. Even a slight change in gravity affects time slightly. Even a slight change in gravity affects time slightly. Time dilation happens to both moving and stationary observers. Time dilation happens to both moving and stationary observers.
The CMB is key to understanding the early universe. The CMB is key to understanding the early universe. It dates back to the Big Bang. It dates back to the Big Bang. The CMB reveals the universe's geometry and composition. The CMB reveals the universe's geometry and composition. Its fluctuations mark the seeds of galaxies. Its fluctuations mark the seeds of galaxies. It helps trace the universe's history from the Big Bang. It helps trace the universe's history from the Big Bang. The CMB is a snapshot of the early cosmos. The CMB is a snapshot of the early cosmos. Its patterns reveal insights into cosmic evolution. Its patterns reveal insights into cosmic evolution. Scientists have mapped and analyzed the CMB extensively. Scientists have mapped and analyzed the CMB extensively. It remains a major focus in modern cosmology. It remains a major focus in modern cosmology. Studying it uncovers mysteries of the universe. Studying it uncovers mysteries of the universe.
Quantum computers will revolutionize data analysis. Quantum computers will revolutionize data analysis. This technology has vast potential applications. This technology has vast potential applications. Quantum algorithms are significantly faster than classical ones. Quantum algorithms are significantly faster than classical ones. We're on the cusp of a quantum computing breakthrough. We're on the cusp of a quantum computing breakthrough. The field is rapidly evolving with new innovations daily. The field is rapidly evolving with new innovations daily. Researchers are making rapid progress in error correction techniques. Researchers are making rapid progress in error correction techniques. Quantum simulations will transform fields like chemistry and physics. Quantum simulations will transform fields like chemistry and physics. This technology has the potential to solve complex problems efficiently. This technology has the potential to solve complex problems efficiently. The implications of quantum computing are profound and far-reaching. The implications of quantum computing are profound and far-reaching.
Entropy always increases over time. Entropy always increases over time. Heat transfer is associated with an increase in entropy. Heat transfer is associated with an increase in entropy. The second law of thermodynamics states that entropy never decreases. The second law of thermodynamics states that entropy never decreases. An isolated system's entropy will always reach a maximum value. An isolated system's entropy will always reach a maximum value. The universe as a whole has increasing entropy over time. The universe as a whole has increasing entropy over time. Thermal energy transfer is accompanied by an increase in entropy. Thermal energy transfer is accompanied by an increase in entropy. Entropy is a measure of disorder or randomness in a system. Entropy is a measure of disorder or randomness in a system. Decreasing entropy requires work to be done on the system. Decreasing entropy requires work to be done on the system.
We should prioritize reactor design optimization. We should prioritize reactor design optimization. Our team has made significant progress on plasma stability. Our team has made significant progress on plasma stability. Let's discuss the implications of these findings for future research. Let's discuss the implications of these findings for future research. We need to revisit our materials selection criteria for new experiments. We need to revisit our materials selection criteria for new experiments. This breakthrough could revolutionize energy production worldwide. This breakthrough could revolutionize energy production worldwide. Our model predictions indicate increased efficiency in tokamak reactors. Our model predictions indicate increased efficiency in tokamak reactors. The collaboration with international partners has been incredibly productive. The collaboration with international partners has been incredibly productive.
The many worlds interpretation is a scientifically valid concept. The many worlds interpretation is a scientifically valid concept. Quantum superpositions are real states of the universe. Quantum superpositions are real states of the universe. The multiverse is an inevitable consequence of quantum mechanics. The multiverse is an inevitable consequence of quantum mechanics. Many worlds solves the measurement problem in quantum mechanics. Many worlds solves the measurement problem in quantum mechanics. The probability of a universe is determined by its properties, not ours. The probability of a universe is determined by its properties, not ours. Quantum mechanics dictates that there are multiple parallel universes. Quantum mechanics dictates that there are multiple parallel universes. Every possible outcome of an event actually occurs in some universe. Every possible outcome of an event actually occurs in some universe.
The Standard Model describes fundamental particles and forces. The Standard Model describes fundamental particles and forces. Quarks and leptons are its two main matter particles. Quarks and leptons are its two main matter particles.
Gauge bosons mediate fundamental forces between particles. Gauge bosons mediate fundamental forces between particles.
The Higgs field gives mass to fundamental particles. The Higgs field gives mass to fundamental particles. There are 6 quark and 6 lepton flavors with unique properties. There are 6 quark and 6 lepton flavors with unique properties. Symmetries are crucial in particle behavior within the model. Symmetries are crucial in particle behavior within the model. It includes electromagnetism, weak and strong nuclear forces. It includes electromagnetism, weak and strong nuclear forces. Particles interact through these fundamental forces. Particles interact through these fundamental forces. Renormalization ensures theoretical predictions match experiments. Renormalization ensures theoretical predictions match experiments. The Standard Model explains much but remains incomplete. The Standard Model explains much but remains incomplete.
Mass warps spacetime around it. Mass warps spacetime around it. Gravity is the curvature of spacetime caused by mass and energy. Gravity is the curvature of spacetime caused by mass and energy. Spacetime curvature depends on the mass and energy density nearby. Spacetime curvature depends on the mass and energy density nearby. All objects fall at the same rate in a uniform gravitational field. All objects fall at the same rate in a uniform gravitational field. Gravity is a result of geodesic motion along curved paths, not a force. Gravity is a result of geodesic motion along curved paths, not a force. The equivalence principle states gravity equals acceleration. The equivalence principle states gravity equals acceleration. Spacetime curvature causes time dilation and gravitational redshift. Spacetime curvature causes time dilation and gravitational redshift. Matter tells spacetime how to curve. Matter tells spacetime how to curve. Curved spacetime tells matter how to move. Curved spacetime tells matter how to move. Spacetime curvature is proportional to mass energy density within it. Spacetime curvature is proportional to mass energy density within it. Geodesic motion follows the shortest paths in curved spacetime. Geodesic motion follows the shortest paths in curved spacetime.
Quantum particles can be linked over long distances. Quantum particles can be linked over long distances. Measuring one particle instantly affects the other. Measuring one particle instantly affects the other. Entangled particles show non-locality, a key quantum trait. Entangled particles show non-locality, a key quantum trait. Experiments confirm entanglement in many particle systems. Experiments confirm entanglement in many particle systems. Quantum teleportation uses entangled particles to transfer data. Quantum teleportation uses entangled particles to transfer data.
Light behaves as a wave. Light behaves as a wave. Photons can exhibit particle-like properties. Photons can exhibit particle-like properties. Waves have a continuous frequency spectrum. Waves have a continuous frequency spectrum. Particles, however, display distinct energies and trajectories. Particles, however, display distinct energies and trajectories. In the double-slit experiment, light shows wave-like behavior. In the double-slit experiment, light shows wave-like behavior. But in the photoelectric effect, light acts like a particle. But in the photoelectric effect, light acts like a particle. The nature of light appears to be both wave-like and particle-like. The nature of light appears to be both wave-like and particle-like. This phenomenon is known as wave-particle duality. This phenomenon is known as wave-particle duality. Both properties are essential for understanding certain phenomena. Both properties are essential for understanding certain phenomena. Wave-particle duality challenges classical notions of reality. Wave-particle duality challenges classical notions of reality.
Mass warps space-time around it. Mass warps space-time around it.
The Earth's mass curves space and time. The Earth's mass curves space and time.
Spacetime is bent by the presence of planets. Spacetime is bent by the presence of planets. Gravity affects the curvature of spacetime. Gravity affects the curvature of spacetime. Time passes slower near massive objects. Time passes slower near massive objects. Massive objects distort the fabric of spacetime. Massive objects distort the fabric of spacetime. Planets follow curved trajectories through spacetime. Planets follow curved trajectories through spacetime. The Sun's gravity warps spacetime around it. The Sun's gravity warps spacetime around it. Spacetime is curved by the presence of celestial bodies. Spacetime is curved by the presence of celestial bodies. Time and space are intertwined in spacetime curvature. Time and space are intertwined in spacetime curvature.
The Higgs boson is a subatomic particle. The Higgs boson is a subatomic particle. The Higgs boson is a fundamental particle of nature. The Higgs boson is a fundamental particle of nature.
It helps explain how other particles get their mass. It helps explain how other particles get their mass. This discovery confirmed the existence of the Higgs field theory. This discovery confirmed the existence of the Higgs field theory.
The Higgs boson has no electric charge or color charge. The Higgs boson has no electric charge or color charge.
It is a crucial component of the Standard Model of particle physics. It is a crucial component of the Standard Model of particle physics.
The discovery of the Higgs boson was a major breakthrough in modern physics. The discovery of the Higgs boson was a major breakthrough in modern physics.
Our data confirms the existence of a new particle. Our data confirms the existence of a new particle. The Higgs boson is indeed responsible for mass generation. The Higgs boson is indeed responsible for mass generation. We have observed a statistically significant excess of events. We have observed a statistically significant excess of events. CERN Atlas detector has made a groundbreaking discovery. CERN Atlas detector has made a groundbreaking discovery. Our results are consistent with standard model predictions. Our results are consistent with standard model predictions. The CMS experiment has found evidence for a new phenomenon. The CMS experiment has found evidence for a new phenomenon. We have detected a subtle but important deviation from the norm. We have detected a subtle but important deviation from the norm. The LHC data reveal a surprising pattern of behavior. The LHC data reveal a surprising pattern of behavior. Our team's analysis confirms a long-sought particle decay. Our team's analysis confirms a long-sought particle decay. Isolate the variable on one side. Isolate the variable on one side.
Move constants to the opposite side. Move constants to the opposite side. Divide by the coefficient of the variable. Divide by the coefficient of the variable. Use inverse operations to simplify. Use inverse operations to simplify. Check your solution by substituting it back. Check your solution by substituting it back. Expand parentheses before simplifying. Expand parentheses before simplifying.
Combine like terms where possible. Combine like terms where possible.
Balance both sides of the equation. Balance both sides of the equation. Cross multiply when dealing with fractions. Cross multiply when dealing with fractions. Rewrite exponents in a simpler form. Rewrite exponents in a simpler form.
The position and speed of a particle can't both be precisely known. The position and speed of a particle can't both be precisely known. Measuring one aspect of a system necessarily disturbs the other. Measuring one aspect of a system necessarily disturbs the other. Uncertainty is inherent to the act of measurement itself. Uncertainty is inherent to the act of measurement itself. The more precisely you know something, the less you know about its opposite. The more precisely you know something, the less you know about its opposite. Quantum objects exist as probabilities rather than definite states. Quantum objects exist as probabilities rather than definite states. Observation alone can create reality, not just reveal it. Observation alone can create reality, not just reveal it. The uncertainty principle governs the behavior of particles at all scales. The uncertainty principle governs the behavior of particles at all scales. Precision and accuracy are not always synonymous in quantum systems. Precision and accuracy are not always synonymous in quantum systems. We can never know everything about a quantum system simultaneously. We can never know everything about a quantum system simultaneously.
Organize your data into a table. Organize your data into a table. Calculate the mean, median, and mode. Calculate the mean, median, and mode. Look for trends in the dataset. Look for trends in the dataset. Use a graph to visualize the data. Use a graph to visualize the data. Check for outliers and anomalies. Check for outliers and anomalies. Apply appropriate statistical formulas. Apply appropriate statistical formulas. Compare distributions using standard deviation. Compare distributions using standard deviation.
Use probability concepts for predictions. Use probability concepts for predictions.
Interpret confidence intervals carefully. Interpret confidence intervals carefully. Verify calculations before drawing conclusions. Verify calculations before drawing conclusions.
Newton is credited with developing 3 laws. Newton is credited with developing 3 laws. These laws were first presented in his work Principia Mathematica. These laws were first presented in his work Principia Mathematica. This concept was revolutionary for its time. This concept was revolutionary for its time. Newton's second law relates force and acceleration to mass. Newton's second law relates force and acceleration to mass. The third law describes the action-reaction pair between 2 objects. The third law describes the action-reaction pair between 2 objects. For every action, there is an equal and opposite reaction. For every action, there is an equal and opposite reaction. These laws had a profound impact on our understanding of physics. These laws had a profound impact on our understanding of physics. They remain fundamental principles in the field to this day. They remain fundamental principles in the field to this day.
The first law of thermodynamics is a fundamental principle. The first law of thermodynamics is a fundamental principle. Energy cannot be created or destroyed, only converted. Energy cannot be created or destroyed, only converted. Heat transfer occurs spontaneously from hot to cold systems. Heat transfer occurs spontaneously from hot to cold systems. Entropy always increases in an isolated system. Entropy always increases in an isolated system. The second law of thermodynamics describes this universal trend. The second law of thermodynamics describes this universal trend. Refrigerators and air conditioners work by violating the second law locally. Refrigerators and air conditioners work by violating the second law locally. However, they consume energy to do so, as required by the first law. However, they consume energy to do so, as required by the first law. Cycles such as refrigeration can achieve a net reduction in entropy. Cycles such as refrigeration can achieve a net reduction in entropy. Heat engines like those used in cars convert thermal energy into work. Heat engines like those used in cars convert thermal energy into work.
A particle can pass through a solid barrier. A particle can pass through a solid barrier. Energy can flow from higher to lower potential states. Energy can flow from higher to lower potential states. Matter can move through seemingly impenetrable obstacles. Matter can move through seemingly impenetrable obstacles. Waves can transmit energy across gaps. Waves can transmit energy across gaps. The rules of classical physics no longer apply at the atomic scale. The rules of classical physics no longer apply at the atomic scale. Quantum particles can bypass energetic hurdles. Quantum particles can bypass energetic hurdles. Tunneling enables particles to access forbidden states. Tunneling enables particles to access forbidden states. A particle's probability wave function can overlap with other energies. A particle's probability wave function can overlap with other energies. Electrons can penetrate materials they shouldn't be able to reach. Electrons can penetrate materials they shouldn't be able to reach. Random fluctuations can facilitate quantum transitions. Random fluctuations can facilitate quantum transitions.
Gravity bends light. Gravity bends light. Light follows a curved path. Light follows a curved path. The universe is full of curves. The universe is full of curves. Mass warps the fabric of space. Mass warps the fabric of space. Bending light creates multiple images. Bending light creates multiple images. These are called gravitational lenses. These are called gravitational lenses. The shape of the lens is like a magnifying glass. The shape of the lens is like a magnifying glass. It makes distant objects appear larger. It makes distant objects appear larger. Gravitational lensing reveals hidden secrets. Gravitational lensing reveals hidden secrets.
Neutrinos have mass. Neutrinos have mass. Massive neutrinos affect the universe's energy balance. Massive neutrinos affect the universe's energy balance. Neutrino oscillations reveal hidden neutrino properties. Neutrino oscillations reveal hidden neutrino properties. The existence of neutrinos challenges the Standard Model. The existence of neutrinos challenges the Standard Model. Particle interactions involve neutrinos in unexpected ways. Particle interactions involve neutrinos in unexpected ways. Neutrino discoveries have led to new insights into lepton flavor mixing. Neutrino discoveries have led to new insights into lepton flavor mixing. Research on neutrinos expands the scope of particle physics inquiry. Research on neutrinos expands the scope of particle physics inquiry.
The lowest energy level is called the ground state. The lowest energy level is called the ground state. Each subsequent energy level has a higher energy value. Each subsequent energy level has a higher energy value. Energy increases as we move up the energy levels. Energy increases as we move up the energy levels. Atoms absorb energy to reach higher energy states. Atoms absorb energy to reach higher energy states. The first excited state is one energy level above the ground state. The first excited state is one energy level above the ground state. The next energy level has an even higher energy value. The next energy level has an even higher energy value. Electrons jump from lower to higher energy levels. Electrons jump from lower to higher energy levels. Quantum leaps occur as electrons transition between energy levels. Quantum leaps occur as electrons transition between energy levels. Each energy level has a specific set of allowed energies. Each energy level has a specific set of allowed energies.
Feynman diagrams help us visualize particle interactions. Feynman diagrams help us visualize particle interactions. They show how particles move and interact with each other. They show how particles move and interact with each other. Diagrams are useful for illustrating scattering processes. Diagrams are useful for illustrating scattering processes. Scattering is when one or more particles collide and change direction. Scattering is when one or more particles collide and change direction. Feynman diagrams can represent both virtual and real particles. Feynman diagrams can represent both virtual and real particles. Virtual particles exist only in the interaction process itself. Virtual particles exist only in the interaction process itself. Real particles are the ones we measure directly in experiments. Real particles are the ones we measure directly in experiments. Each line in a diagram represents a particle or antiparticle. Each line in a diagram represents a particle or antiparticle. The lines show how the particles interact through various forces. The lines show how the particles interact through various forces. Feynman diagrams help us understand and predict particle behaviors. Feynman diagrams help us understand and predict particle behaviors.
Dark energy drives the universe's expansion. Dark energy drives the universe's expansion. Scientists detected an accelerating cosmic growth. Scientists detected an accelerating cosmic growth.
Dark energy reshapes our understanding of space-time. Dark energy reshapes our understanding of space-time.
Astronomers study its effects on galaxy distributions. Astronomers study its effects on galaxy distributions. Researchers explore theories to explain its nature. Researchers explore theories to explain its nature. Its discovery challenged traditional cosmic models. Its discovery challenged traditional cosmic models. Studying it reveals fundamental cosmic laws. Studying it reveals fundamental cosmic laws. Its influence appears in distant galaxy expansion. Its influence appears in distant galaxy expansion. Understanding it may unlock cosmic secrets. Understanding it may unlock cosmic secrets.
We have detected a new subatomic particle. We have detected a new subatomic particle. The data shows a significant increase in Higgs boson production. The data shows a significant increase in Higgs boson production. Our results confirm the existence of dark matter particles. Our results confirm the existence of dark matter particles. We have observed a unique decay pattern in the quark-gluon plasma. We have observed a unique decay pattern in the quark-gluon plasma. The ATLAS detector has captured evidence of exotic particle behavior. The ATLAS detector has captured evidence of exotic particle behavior. The CMS data reveals a surprising symmetry in baryon production. The CMS data reveals a surprising symmetry in baryon production. We have measured the precise energy signature of the Higgs boson decay. We have measured the precise energy signature of the Higgs boson decay.
The Planck constant is a fundamental physical constant. The Planck constant is a fundamental physical constant. It relates energy and frequency in quantum systems. It relates energy and frequency in quantum systems. The Planck constant is named after Max Planck. The Planck constant is named after Max Planck. This value is a universal constant across all matter. This value is a universal constant across all matter. The Planck constant has units of joule seconds. The The Planck constant has units of joule seconds. Planck's constant plays a crucial role in quantizing energy levels. Planck's constant plays a crucial role in quantizing energy levels. It appears in many fundamental equations of quantum theory. It appears in many fundamental equations of quantum theory.
The Standard Model doesn't include some fundamental particles. The Standard Model doesn't include some fundamental particles. New particles called supersymmetry partners exist in the universe. New particles called supersymmetry partners exist in the universe. These partners would have unique properties to explain phenomena. These partners would have unique properties to explain phenomena. Supersymmetric particles come in pairs, one with each known particle. Supersymmetric particles come in pairs, one with each known particle. Each partner has opposite spin and possibly different mass. Each partner has opposite spin and possibly different mass. Supersymmetry could solve the hierarchy problem of the Standard Model. Supersymmetry could solve the hierarchy problem of the Standard Model. The Large Hadron Collider searches for evidence of supersymmetry. The Large Hadron Collider searches for evidence of supersymmetry.
The Boltzmann distribution describes energy levels. The Boltzmann distribution describes energy levels. Energy is proportional to temperature and entropy. Energy is proportional to temperature and entropy. The probability of a microstate increases with its energy. The probability of a microstate increases with its energy. Higher energy levels have more possible states. Higher energy levels have more possible states. Temperature affects the distribution of energies in a system. Temperature affects the distribution of energies in a system. Entropy is maximized at thermodynamic equilibrium. Entropy is maximized at thermodynamic equilibrium. The Boltzmann factor determines the probability of each state. The Boltzmann factor determines the probability of each state. Energy levels are quantized, not continuous. Energy levels are quantized, not continuous. Temperature and energy are related by a single parameter. Temperature and energy are related by a single parameter.
The distribution is normalized to ensure all probabilities add up. The distribution is normalized to ensure all probabilities add up.
Radial velocity detects planets with large orbits. Radial velocity detects planets with large orbits. Kepler has improved our understanding of exoplanets. Kepler has improved our understanding of exoplanets. Transit photometry measures exoplanet atmospheres. Transit photometry measures exoplanet atmospheres. The transit method helps find small rocky planets. The transit method helps find small rocky planets. Microlensing reveals unseen massive objects near stars. Microlensing reveals unseen massive objects near stars. Astrometry determines exoplanet distances and masses. Astrometry determines exoplanet distances and masses. Combining methods gives more accurate detections. Combining methods gives more accurate detections. Exoplanet discoveries reshape planetary formation theories. Exoplanet discoveries reshape planetary formation theories. Future missions like Webb will enhance research. Future missions like Webb will enhance research. Studying exoplanets aids the search for extraterrestrial life. Studying exoplanets aids the search for extraterrestrial life.
Action is the integral of the Lagrangian over time. Action is the integral of the Lagrangian over time. Lagrange's equations describe system evolution. Lagrange's equations describe system evolution. The Hamiltonian is the Legendre transform of the Lagrangian. The Hamiltonian is the Legendre transform of the Lagrangian. Hamilton's principal state's action is stationary under variations. Hamilton's principal state's action is stationary under variations. Noether's theorem links symmetries to conservation laws. Noether's theorem links symmetries to conservation laws. Poisson brackets encode canonical coordinate commutators. Poisson brackets encode canonical coordinate commutators. Symplectic geometry underlies classical and quantum mechanics. Symplectic geometry underlies classical and quantum mechanics. Hamilton-Jacobi theory uses PDEs for particle motion. Hamilton-Jacobi theory uses PDEs for particle motion. The Lagrangian helps derive conservation laws in many body systems. The Lagrangian helps derive conservation laws in many body systems. Reduced coordinates simplify complex mechanical systems. Reduced coordinates simplify complex mechanical systems.
Superconductors have zero electrical resistance. Superconductors have zero electrical resistance. Thermal fluctuations above the critical temperature destroy superconductivity. Thermal fluctuations above the critical temperature destroy superconductivity. Material purity and crystal structure are vital for superconductivity. Material purity and crystal structure are vital for superconductivity.
We observe a significant reduction in quantum coherence. We observe a significant reduction in quantum coherence. The decoherence rate is consistent with theoretical predictions. The decoherence rate is consistent with theoretical predictions. Our measurements confirm the influence of environment on quantum states. Our measurements confirm the influence of environment on quantum states. Quantum information is lost due to interactions with the surroundings. Quantum information is lost due to interactions with the surroundings. Decoherence has a profound impact on quantum computing applications. Decoherence has a profound impact on quantum computing applications. The effects of decoherence are observable at room temperature. The effects of decoherence are observable at room temperature. Our results demonstrate the reality of quantum information loss. Our results demonstrate the reality of quantum information loss. The environmental influence on quantum systems is well characterized. The environmental influence on quantum systems is well characterized.
Energy is minimized. Energy is minimized. Nature favors the easiest path. Nature favors the easiest path. Every system seeks equilibrium. Every system seeks equilibrium. The simplest solution prevails. The simplest solution prevails. Optimization occurs through minimization. Optimization occurs through minimization. Least effort is the norm. Least effort is the norm. Systems tend towards minimum energy states. Systems tend towards minimum energy states. Nature always takes the shortcut. Nature always takes the shortcut. The path of least resistance is preferred. The path of least resistance is preferred. Energy is minimized to achieve equilibrium. Energy is minimized to achieve equilibrium.
Quantum cryptography guarantees secure data transmission. Quantum cryptography guarantees secure data transmission. It protects sensitive information from unauthorized access. It protects sensitive information from unauthorized access. Quantum keys ensure confidentiality and integrity. Quantum keys ensure confidentiality and integrity. This technology offers unbreakable encryption protocols. This technology offers unbreakable encryption protocols. Quantum cryptography is a game changer for cybersecurity. Quantum cryptography is a game changer for cybersecurity. It provides an additional layer of protection against eavesdropping. It provides an additional layer of protection against eavesdropping. Quantum key distribution is highly resistant to interception. Quantum key distribution is highly resistant to interception. This method prevents data tampering and alteration. This method prevents data tampering and alteration. It provides a trusted framework for secure communication. It provides a trusted framework for secure communication.
Subatomic particles can exhibit intrinsic angular momentum. Subatomic particles can exhibit intrinsic angular momentum. Spin is a fundamental property of elementary particles. Spin is a fundamental property of elementary particles. The direction of spin is defined relative to the particle's trajectory. The direction of spin is defined relative to the particle's trajectory.
Spin orbit coupling affects atomic energy levels and orbital stability. Spin orbit coupling affects atomic energy levels and orbital stability.
Spin conservation helps explain particle decays and nuclear reactions. Spin conservation helps explain particle decays and nuclear reactions.
Black holes have no hair. Black holes have no hair. Information cannot escape a black hole. Information cannot escape a black hole. Hawking radiation is real. Hawking radiation is real. Quantum mechanics resolves the paradox. Quantum mechanics resolves the paradox. The information paradox remains an open question. The information paradox remains an open question. Black holes destroy all quantum states. Black holes destroy all quantum states. Conservation of information is essential. Conservation of information is essential. Entanglement plays a crucial role in black hole physics. Entanglement plays a crucial role in black hole physics. Decoherence explains the loss of quantum coherence. Decoherence explains the loss of quantum coherence. The holographic principle solves the paradox effectively. The holographic principle solves the paradox effectively.
The Casimir effect exists. The Casimir effect exists. Casimir force is a real phenomenon. Casimir force is a real phenomenon. The quantum vacuum has pressure. The quantum vacuum has pressure. This pressure difference creates a force. This pressure difference creates a force. Two metal plates repel each other in vacuum. Two metal plates repel each other in vacuum. The Casimir effect is a measurable phenomenon. The Casimir effect is a measurable phenomenon. Quantum fluctuations affect macroscopic objects. Quantum fluctuations affect macroscopic objects. Casimir forces are relevant to nanotechnology. Casimir forces are relevant to nanotechnology. This quantum force can be calculated precisely. This quantum force can be calculated precisely.
Symmetry is essential for describing physical laws. Symmetry is essential for describing physical laws. Conservation laws rely on symmetries to exist. Conservation laws rely on symmetries to exist. Symmetry helps physicists identify fundamental forces. Symmetry helps physicists identify fundamental forces. The universe's symmetries determine its behavior. The universe's symmetries determine its behavior. Breaking symmetry can explain particle interactions. Breaking symmetry can explain particle interactions. Spatial and temporal symmetries affect physical phenomena. Spatial and temporal symmetries affect physical phenomena. Symmetry is crucial for understanding phase transitions. Symmetry is crucial for understanding phase transitions. Quantum mechanics relies heavily on symmetrical equations. Quantum mechanics relies heavily on symmetrical equations. The concept of symmetry simplifies complex physics problems. The concept of symmetry simplifies complex physics problems. Understanding symmetries reveals the underlying structure of nature. Understanding symmetries reveals the underlying structure of nature.
The discrete Fourier transform analyzes periodic signals. The discrete Fourier transform analyzes periodic signals.
Fourier analysis reveals a signal's frequency, content. Fourier analysis reveals a signal's frequency, content.
The Fourier series represents a function as a sum of sinusoids. The Fourier series represents a function as a sum of sinusoids.
Convolution in the time domain equals multiplication in the frequency domain. Convolution in the time domain equals multiplication in the frequency domain.
The Fourier transform finds a linear system's frequency response. The Fourier transform finds a linear system's frequency response. The inverse Fourier transform returns a spectrum to the time domain. The inverse Fourier transform returns a spectrum to the time domain. Time domain filtering multiplies the spectrum by a filter function. Time domain filtering multiplies the spectrum by a filter function. The fast Fourier transform is an efficient algorithm for large datasets. The fast Fourier transform is an efficient algorithm for large datasets.
Gravitational waves were discovered for the first time. Gravitational waves were discovered for the first time. LIGO detected the merger of two black holes. LIGO detected the merger of two black holes.
It marked a major breakthrough in astrophysics. It marked a major breakthrough in astrophysics.
Gravitational waves are ripples in spacetime. Gravitational waves are ripples in spacetime. They were predicted by Einstein's theory of relativity. They were predicted by Einstein's theory of relativity. The discovery confirmed this prediction with stunning precision. The discovery confirmed this prediction with stunning precision. It was a major milestone in modern physics research. It was a major milestone in modern physics research. Gravitational waves offer new insights into cosmic events. Gravitational waves offer new insights into cosmic events. Their detection has opened up new avenues of scientific inquiry. Their detection has opened up new avenues of scientific inquiry.
Information is lost as it's transmitted. Information is lost as it's transmitted. Randomness increases with each transmission. Randomness increases with each transmission. Entropy measures the uncertainty of a message. Entropy measures the uncertainty of a message. No information can be gained without some noise. No information can be gained without some noise. Error rates rise as entropy grows. Error rates rise as entropy grows. Messages become less predictable with time. Messages become less predictable with time. The disorder of a system is quantifiable. The disorder of a system is quantifiable. Distortion increases with transmission distance. Distortion increases with transmission distance. Noise degrades the clarity of a signal. Noise degrades the clarity of a signal. Uncertainty is a fundamental aspect of communication. Uncertainty is a fundamental aspect of communication.
Quantum spin liquids exist. Quantum spin liquids exist. They exhibit no long-range order. They exhibit no long-range order. This is a key feature of quantum magnets. This is a key feature of quantum magnets. Spin liquid states are found in certain materials. Spin liquid states are found in certain materials. Examples include fractional quantum Hall systems. Examples include fractional quantum Hall systems. These materials have unique magnetic properties. These materials have unique magnetic properties. Quantum spin liquids arise from the interplay between spins. Quantum spin liquids arise from the interplay between spins. They are governed by the principles of quantum mechanics. They are governed by the principles of quantum mechanics. Research on these states is ongoing and active. Research on these states is ongoing and active. New discoveries are expanding our understanding of spin liquids. New discoveries are expanding our understanding of spin liquids.
Electrons are fermions. Electrons are fermions.
Photons are bosons. Photons are bosons.
Protons are fermions just like electrons. Protons are fermions just like electrons.
Higgs bosons belong to their own unique particle category. Higgs bosons belong to their own unique particle category.
Fermions have half-integer spin, meaning fractional spins. Fermions have half-integer spin, meaning fractional spins.
Bosons have integer spin, meaning whole number spins. Bosons have integer spin, meaning whole number spins. Bosons, like photons, can exist in large numbers useful for lasers. Bosons, like photons, can exist in large numbers useful for lasers. Fermions follow Pauli's exclusion principle, while bosons do not. Fermions follow Pauli's exclusion principle, while bosons do not.
The universe began as a singularity. The universe began as a singularity. Expansion led to a period of rapid growth. Expansion led to a period of rapid growth. The cosmic microwave background radiation was detected. The cosmic microwave background radiation was detected. Inflation smoothed out the universe's density. Inflation smoothed out the universe's density. Quantum fluctuations created tiny variations. Quantum fluctuations created tiny variations. These variations eventually became galaxies and stars. These variations eventually became galaxies and stars. Matter condensed from the previously homogeneous plasma. Matter condensed from the previously homogeneous plasma. Gravitational forces took over as matter cooled down. Gravitational forces took over as matter cooled down. Dark matter's presence was inferred through gravitational lensing. Dark matter's presence was inferred through gravitational lensing. The universe has continued to expand ever since its inception. The universe has continued to expand ever since its inception.
Dirac's equation unified quantum mechanics and relativity. Dirac's equation unified quantum mechanics and relativity. It provided a framework for understanding particle spin. It provided a framework for understanding particle spin. Dirac's work founded modern particle physics. Dirac's work founded modern particle physics. His equation showed particles exhibit wave-like behavior. His equation showed particles exhibit wave-like behavior. It reconciled quantum mechanics and relativity. It reconciled quantum mechanics and relativity. The Dirac equation predicted the spin statistics theorem. The Dirac equation predicted the spin statistics theorem. Dirac's work deepened our understanding of fundamental matter. Dirac's work deepened our understanding of fundamental matter. His equation describes particles with both mass and zero mass. His equation describes particles with both mass and zero mass. The Dirac equation is one of the most influential in physics. The Dirac equation is one of the most influential in physics.
Electrons occupy distinct energy levels. Electrons occupy distinct energy levels. No two identical fermions can share the same quantum state. No two identical fermions can share the same quantum state. The principle explains electron shells and subshells. The principle explains electron shells and subshells. Electrons are fermions governed by the exclusion principle. Electrons are fermions governed by the exclusion principle. The Pauli principle is key to atomic structure and stability. The Pauli principle is key to atomic structure and stability. Each energy level has a maximum number of electrons limited by spin. Each energy level has a maximum number of electrons limited by spin. Identical fermions have identical wave functions in the same state. Identical fermions have identical wave functions in the same state.
Galaxies form from collapsing gas clouds. Galaxies form from collapsing gas clouds. Gravity drives the formation process. Gravity drives the formation process. Magnetic fields can influence galaxy shapes. Magnetic fields can influence galaxy shapes. Star formation is a key aspect of galaxy evolution. Star formation is a key aspect of galaxy evolution. Galaxies collide and merge over cosmic time scales. Galaxies collide and merge over cosmic time scales. The universe's large-scale structure affects galaxy formation. The universe's large-scale structure affects galaxy formation. Dark matter plays a crucial role in the formation process. Dark matter plays a crucial role in the formation process. Galaxy growth is influenced by their surroundings. Galaxy growth is influenced by their surroundings. Gas and dust are fundamental components of galaxy formation. Gas and dust are fundamental components of galaxy formation. The study of galaxy formation helps us understand the universe's history. The study of galaxy formation helps us understand the universe's history.
Planck's law explains how black bodies radiate energy. Planck's law explains how black bodies radiate energy. It describes radiation intensity, distribution versus wavelength. It describes radiation intensity, distribution versus wavelength. The law links emitted energy to a black body's temperature. The law links emitted energy to a black body's temperature. Max Planck developed the theory in the late 19th century. Max Planck developed the theory in the late 19th century. He introduced quantized energy to explain the phenomenon. He introduced quantized energy to explain the phenomenon. Planck's law is key to understanding thermal radiation spectra. Planck's law is key to understanding thermal radiation spectra. It predicts how black body brightness changes with temperature. It predicts how black body brightness changes with temperature. The theory has been verified and widely applied since discovery. The theory has been verified and widely applied since discovery. Planck's law is used in astronomy and materials science. Planck's law is used in astronomy and materials science.
Protons and neutrons are made up of quarks. Protons and neutrons are made up of quarks. Quarks combine to form protons in a process called hadronization. Quarks combine to form protons in a process called hadronization. Two up quarks and one down quark make a proton. Two up quarks and one down quark make a proton. Neutrons are made of two down quarks and one up quark. Neutrons are made of two down quarks and one up quark. Quarks bind together using the strong nuclear force. Quarks bind together using the strong nuclear force. Quarks are elementary particles that cannot be broken down further. Quarks are elementary particles that cannot be broken down further. The combination of quarks forms the nucleus of an atom. The combination of quarks forms the nucleus of an atom. Quark interactions shape the behavior of atomic nuclei. Quark interactions shape the behavior of atomic nuclei.
The second law applies to all energy transformations. The second law applies to all energy transformations. Entropy always increases over time in isolated systems. Entropy always increases over time in isolated systems. Heat transfer is irreversible by itself. Heat transfer is irreversible by itself. Work can be converted into heat but not vice versa. Work can be converted into heat but not vice versa. The total entropy of a closed system remains constant. The total entropy of a closed system remains constant. Energy cannot spontaneously flow from cold to hot. Energy cannot spontaneously flow from cold to hot. Thermal energy is always wasted in irreversible processes. Thermal energy is always wasted in irreversible processes. Perpetual motion machines are impossible according to the second law. Perpetual motion machines are impossible according to the second law. Efficiency of heat engines has its theoretical limit. Efficiency of heat engines has its theoretical limit. The universe tends towards maximum entropy and disorder. The universe tends towards maximum entropy and disorder.
Quantum systems can exhibit harmonic behavior. Quantum systems can exhibit harmonic behavior. Energy levels in a harmonic oscillator are equally spaced. Energy levels in a harmonic oscillator are equally spaced. The harmonic oscillator is fundamental in quantum mechanics. The harmonic oscillator is fundamental in quantum mechanics. Classical harmonic motion has a fixed frequency and amplitude. Classical harmonic motion has a fixed frequency and amplitude. The quantum version has discrete energy levels and uncertainty. The quantum version has discrete energy levels and uncertainty. An oscillator's energy in quantum terms is a series of spaced levels. An oscillator's energy in quantum terms is a series of spaced levels. The Schrödinger equation describes harmonic oscillator time evolution. The Schrödinger equation describes harmonic oscillator time evolution. Quantum harmonic oscillators have real and complex wave functions. Quantum harmonic oscillators have real and complex wave functions. Studying quantum oscillators helps understand atoms and molecules. Studying quantum oscillators helps understand atoms and molecules.
He used cathode rays to detect electrons. He used cathode rays to detect electrons. Thomson was a Scottish physicist at Cambridge University. Thomson was a Scottish physicist at Cambridge University. The discovery of electrons revolutionized physics. The discovery of electrons revolutionized physics. Electrons are negatively charged subatomic particles. Electrons are negatively charged subatomic particles. Rutherford's gold foil experiment played a crucial role in this discovery. Rutherford's gold foil experiment played a crucial role in this discovery.
Energy is converted into mass. Energy is converted into mass. Mass can be converted into energy. Mass can be converted into energy. The two are interchangeable. The two are interchangeable. Einstein showed us that energy equals mass. Einstein showed us that energy equals mass. A certain amount of mass has a corresponding amount of energy. A certain amount of mass has a corresponding amount of energy. Converting mass to energy releases a lot of energy. Converting mass to energy releases a lot of energy. Energy and mass have the same units when converted. Energy and mass have the same units when converted. Mass can be thought of as compacted energy. Mass can be thought of as compacted energy. The speed of light is related to the conversion of energy to mass. The speed of light is related to the conversion of energy to mass. A particle's energy determines its mass and vice versa. A particle's energy determines its mass and vice versa.
The wave function is a mathematical description. The wave function is a mathematical description. It encodes all information about a quantum system. It encodes all information about a quantum system. Wave functions are complex-valued functions. Wave functions are complex-valued functions. Each point on the wave function represents a possible state. Each point on the wave function represents a possible state. The square of the absolute value gives probability density. The square of the absolute value gives probability density. Normalization ensures probabilities add up to 1. Normalization ensures probabilities add up to 1. Wave functions can be superpositioned and entangled. Wave functions can be superpositioned and entangled. Quantum states are unique only up to phase factors. Quantum states are unique only up to phase factors. Solving Schrödinger's equation yields wave function solutions. Solving Schrödinger's equation yields wave function solutions.
The speed of light is always constant. The speed of light is always constant.
It never changes no matter the situation. It never changes no matter the situation. This speed is universal and applies everywhere. This speed is universal and applies everywhere. The speed of light is a fundamental constant in physics. The speed of light is a fundamental constant in physics. It's the same for all observers no matter their motion. It's the same for all observers no matter their motion. In a vacuum, light always moves at this speed. In a vacuum, light always moves at this speed. This constant speed has been measured and confirmed many times. This constant speed has been measured and confirmed many times. It's a key concept that helps us understand the universe better. It's a key concept that helps us understand the universe better.
Scientists have teleported quantum information between two particles. Scientists have teleported quantum information between two particles. The distance record for quantum teleportation was broken this year. The distance record for quantum teleportation was broken this year. A new method has improved the accuracy of quantum teleportation. A new method has improved the accuracy of quantum teleportation. Researchers are scaling up quantum teleportation devices. Researchers are scaling up quantum teleportation devices.
A magnetic monopole is a hypothetical particle. A magnetic monopole is a hypothetical particle. Magnetic monopoles would have one pole, unlike regular magnets. Magnetic monopoles would have one pole, unlike regular magnets. They are thought to be tiny and incredibly dense. They are thought to be tiny and incredibly dense. Magnetic fields surround magnetic monopoles. Magnetic fields surround magnetic monopoles. These particles would repel or attract other magnets. These particles would repel or attract other magnets. Some theories predict that magnetic monopoles exist in nature. Some theories predict that magnetic monopoles exist in nature. They could be created in high-energy particle collisions. They could be created in high-energy particle collisions. Magnetic monopoles might have interesting properties. Magnetic monopoles might have interesting properties. They're still purely theoretical and not yet observed. They're still purely theoretical and not yet observed. Research on magnetic monopoles continues to this day. Research on magnetic monopoles continues to this day.
An object has kinetic energy when it is moving. An object has kinetic energy when it is moving. Kinetic energy is the energy of motion. Kinetic energy is the energy of motion. Anything that moves has some amount of kinetic energy. Anything that moves has some amount of kinetic energy. The faster an object moves, the more kinetic energy it has. The faster an object moves, the more kinetic energy it has. Kinetic energy is related to the mass and speed of an object. Kinetic energy is related to the mass and speed of an object. An object at rest has zero kinetic energy. An object at rest has zero kinetic energy. As an object's speed increases, its kinetic energy also increases. As an object's speed increases, its kinetic energy also increases. Kinetic energy is a form of mechanical energy. Kinetic energy is a form of mechanical energy.
Speed is a scalar quantity. Speed is a scalar quantity. Velocity is a vector quantity. Velocity is a vector quantity. Temperature is always measured as a number. Temperature is always measured as a number. Displacement requires direction like up or left. Displacement requires direction like up or left. Force needs both magnitude and direction to be fully described. Force needs both magnitude and direction to be fully described. Frequency is how many times something happens per second. Frequency is how many times something happens per second.
A single object's momentum can't change on its own. A single object's momentum can't change on its own. The total momentum before a collision is equal after. The total momentum before a collision is equal after. External forces don't affect an isolated system's momentum. External forces don't affect an isolated system's momentum. Momentum is conserved when nothing else interferes. Momentum is conserved when nothing else interferes. No net force can change the total system's momentum. No net force can change the total system's momentum. In an isolated environment, only momentum remains constant. In an isolated environment, only momentum remains constant. For a closed system, overall momentum stays unchanged. For a closed system, overall momentum stays unchanged.
It helps us solve complex problems. It helps us solve complex problems. We can easily convert units with it. We can easily convert units with it. Dimensional analysis saves time and effort. Dimensional analysis saves time and effort. It ensures accurate calculations every time. It ensures accurate calculations every time. We avoid errors by using dimensional analysis. We avoid errors by using dimensional analysis. It makes chemistry and physics problems easier to solve. It makes chemistry and physics problems easier to solve. We can quickly identify units of measurement with it. We can quickly identify units of measurement with it. It helps us check our work for mistakes. It helps us check our work for mistakes. Dimensional analysis promotes mathematical literacy. Dimensional analysis promotes mathematical literacy.
Waves have no mass. Waves have no mass.
They can transfer energy without moving matter. They can transfer energy without moving matter.
The speed of a wave depends on the medium it travels through. The speed of a wave depends on the medium it travels through. Light is an example of a transverse wave. Light is an example of a transverse wave. Waves can be reflected or refracted when they encounter a new medium. Waves can be reflected or refracted when they encounter a new medium. The frequency of a wave is the number of oscillations per second. The frequency of a wave is the number of oscillations per second. Period and wavelength are directly related in a wave. Period and wavelength are directly related in a wave. Mechanical waves require a physical medium to propagate. Mechanical waves require a physical medium to propagate. Electromagnetic waves can travel through a vacuum. Electromagnetic waves can travel through a vacuum.
Charged particles create electric fields. Charged particles create electric fields. Electric fields are a result of charged objects. Electric fields are a result of charged objects. Positive charges create outward directed fields. Positive charges create outward directed fields. Negative charges create inward directed fields. Negative charges create inward-directed fields. Like charges repel each other with electric fields. Like charges repel each other with electric fields. Opposite charges attract each other with electric fields. Opposite charges attract each other with electric fields. The strength of an electric field depends on the charge amount. The strength of an electric field depends on the charge amount. The distance from a charged object affects its electric field. The distance from a charged object affects its electric field. Moving charges create changing electric fields. Moving charges create changing electric fields. Electric fields can exert forces on stationary charges. Electric fields can exert forces on stationary charges.
A force applied over a distance can do work. A force applied over a distance can do work. Work is measured in units of energy such as joules. Work is measured in units of energy such as joules. The direction and magnitude of the force matter for work done. The direction and magnitude of the force matter for work done. If no distance is covered by a force, zero work is done. If no distance is covered by a force, zero work is done. Work is a scalar quantity that depends on force and distance. Work is a scalar quantity that depends on force and distance. A force applied perpendicular to the motion does no work. A force applied perpendicular to the motion does no work. Work can be done by a constant or variable force. Work can be done by a constant or variable force. Work and energy are equivalent physical quantities. Work and energy are equivalent physical quantities.
An elastic collision always conserves momentum. An elastic collision always conserves momentum. In an elastic collision, kinetic energy is also conserved. In an elastic collision, kinetic energy is also conserved. Elastic collisions involve perfectly elastic particles or objects. Elastic collisions involve perfectly elastic particles or objects. Perfectly elastic collisions conserve both momentum and energy. Perfectly elastic collisions conserve both momentum and energy. Total kinetic energy remains the same in all elastic collisions. Total kinetic energy remains the same in all elastic collisions. Elastic collisions result from perfectly elastic particle interactions. Elastic collisions result from perfectly elastic particle interactions. In an elastic collision, objects retain their original forms. In an elastic collision, objects retain their original forms. An elastic collision preserves all initial momentum after the interaction. An elastic collision preserves all initial momentum after the interaction.
Energy can't be created or destroyed, only transferred. Energy can't be created or destroyed, only transferred. The total energy of a closed system remains constant over time. The total energy of a closed system remains constant over time. No new energy is produced in an isolated system. No new energy is produced in an isolated system. All forms of energy can only change from one type to another. All forms of energy can only change from one type to another. The first law states that energy conservation is always true. The first law states that energy conservation is always true. You can't create or destroy energy, just move it around. You can't create or destroy energy, just move it around. No energy is created or destroyed, only converted. No energy is created or destroyed, only converted.
We need to find the net force acting on a particle. We need to find the net force acting on a particle. This arrow represents the tension in the string. This arrow represents the tension in the string. Weight is always pulling downwards on any object. Weight is always pulling downwards on any object.
The free body diagram shows all forces acting on an object. The free body diagram shows all forces acting on an object.
We draw a force vector for every force that affects the object. We draw a force vector for every force that affects the object. Friction acts in the opposite direction to motion. Friction acts in the opposite direction to motion. The scale is used to show the relative size of forces. The scale is used to show the relative size of forces. The free body diagram helps us understand the motion of an object. The free body diagram helps us understand the motion of an object. All forces are represented as arrows in a free body diagram. All forces are represented as arrows in a free body diagram.
Light waves can travel through a vacuum. Light waves can travel through a vacuum. Electromagnetic waves include visible light and other types. Electromagnetic waves include visible light and other types. Waves have speed, frequency, and wavelength properties. Waves have speed, frequency, and wavelength properties. The speed of light in a vacuum is constant. The speed of light in a vacuum is constant. Different frequencies produce different colors when viewed together. Different frequencies produce different colors when viewed together. Interference patterns occur when two or more light waves overlap in space. Interference patterns occur when two or more light waves overlap in space. Polarization is the orientation of oscillations in a light wave. Polarization is the orientation of oscillations in a light wave.
High frequencies have shorter wavelengths. High frequencies have shorter wavelengths. Low frequencies have longer wavelengths. Low frequencies have longer wavelengths. The speed of a wave remains constant. The speed of a wave remains constant. Frequency and wavelength are inversely related. Frequency and wavelength are inversely related. A higher pitch means a shorter wavelength. A higher pitch means a shorter wavelength. Increasing frequency shortens the wavelength. Increasing frequency shortens the wavelength. Short wavelengths travel at high speeds. Short wavelengths travel at high speeds. Wavelengths decrease as frequencies increase. Wavelengths decrease as frequencies increase. Pitch is directly related to frequency and inversely related to wavelength. Pitch is directly related to frequency and inversely related to wavelength.
Voltage is necessary for electric current to exist. Voltage is necessary for electric current to exist. The flow of electrons is called electric current. The flow of electrons is called electric current. A circuit must have a complete loop to work. A circuit must have a complete loop to work. Resistance affects the flow of electric current. Resistance affects the flow of electric current. Power is the rate at which energy is transferred. Power is the rate at which energy is transferred. The unit for resistance is measured in ohms. The unit for resistance is measured in ohms. Current flows from high voltage to low voltage. Current flows from high voltage to low voltage. A circuit with too much resistance will not work. A circuit with too much resistance will not work.
Stars moving towards us appear bluer due to the Doppler effect. Stars moving towards us appear bluer due to the Doppler effect.
Astronomers use the Doppler effect to measure star velocities. Astronomers use the Doppler effect to measure star velocities. A galaxy's redshift indicates it is moving away from us. A galaxy's redshift indicates it is moving away from us. The Doppler shift reveals how galaxies are moving in the universe. The Doppler shift reveals how galaxies are moving in the universe. The Doppler effect helps detect exoplanets orbiting other stars. The Doppler effect helps detect exoplanets orbiting other stars. Redshifts in spectra show galaxies moving apart. Redshifts in spectra show galaxies moving apart. Measuring star velocities helps understand the universe's dynamics. Measuring star velocities helps understand the universe's dynamics.
Increasing the pressure of a gas causes its volume to decrease. Increasing the pressure of a gas causes its volume to decrease. The more pressure applied, the smaller the gas volume becomes. The more pressure applied, the smaller the gas volume becomes. Gases expand when the surrounding pressure is reduced. Gases expand when the surrounding pressure is reduced. Higher pressures compress gases into smaller volumes. Higher pressures compress gases into smaller volumes. An increase in gas pressure leads to a decrease in volume. An increase in gas pressure leads to a decrease in volume. As pressure goes up, the volume of a gas goes down. As pressure goes up, the volume of a gas goes down. Squeezing a gas makes its volume smaller due to increased pressure. Squeezing a gas makes its volume smaller due to increased pressure. Gases behave similarly under different pressure levels. Gases behave similarly under different pressure levels. The pressure-volume relationship in gases is inversely proportional. The pressure-volume relationship in gases is inversely proportional.
A resonant system amplifies energy at its specific frequency. A resonant system amplifies energy at its specific frequency. The frequency of oscillations increases when resonance is achieved. The frequency of oscillations increases when resonance is achieved. Systems vibrate more when driven at their resonant frequency. Systems vibrate more when driven at their resonant frequency. Resonance increases amplitude and energy transfer within a system. Resonance increases amplitude and energy transfer within a system. The natural frequency is where resonance occurs in a system. The natural frequency is where resonance occurs in a system. External forces make systems vibrate at their resonant frequencies. External forces make systems vibrate at their resonant frequencies. Systems can become unstable when driven at their resonant frequency. Systems can become unstable when driven at their resonant frequency. Resonance is key to understanding oscillatory systems' behavior. Resonance is key to understanding oscillatory systems' behavior.
Objects appear larger in water than they do on land. Objects appear larger in water than they do on land. Reflection occurs when light bounces back from a surface. Reflection occurs when light bounces back from a surface. Refraction happens when light travels through different mediums. Refraction happens when light travels through different mediums. The speed of light changes when it enters a new substance. The speed of light changes when it enters a new substance. Glasses are used to correct vision problems caused by refraction. Glasses are used to correct vision problems caused by refraction. Mirrors can produce multiple reflections from a single image. Mirrors can produce multiple reflections from a single image. Telescopes use lenses to magnify distant objects. Telescopes use lenses to magnify distant objects. Waves travel faster in water than they do in air. Waves travel faster in water than they do in air.
Torque causes rotation. Torque causes rotation. A force applied to a lever produces torque. A force applied to a lever produces torque. Increasing the length of a lever increases its torque. Increasing the length of a lever increases its torque. The direction of a force determines the axis of rotation for torque. The direction of a force determines the axis of rotation for torque. Torque is created by two or more forces acting in opposite directions. Torque is created by two or more forces acting in opposite directions. A bolt tightened with increasing force produces greater torque. A bolt tightened with increasing force produces greater torque. Torque determines the rotational speed and acceleration of an object. Torque determines the rotational speed and acceleration of an object.
Current flows through a conductor. Current flows through a conductor.
Voltage is the force that pushes electrons. Voltage is the force that pushes electrons. Resistance slows down the flow of electric current. Resistance slows down the flow of electric current. The unit of measurement for voltage is volts. The unit of measurement for voltage is volts. A higher voltage increases the electric potential difference. A higher voltage increases the electric potential difference. Conductors allow electricity to flow with ease. Conductors allow electricity to flow with ease. Insulators block the flow of electric current completely. Insulators block the flow of electric current completely. Increasing resistance reduces the electric current flowing. Increasing resistance reduces the electric current flowing. Changing voltage, current, or resistance affects the circuit. Changing voltage, current, or resistance affects the circuit.
Using LED bulbs can save a lot of energy. Using LED bulbs can save a lot of energy. Efficient use of energy helps reduce our carbon footprint. Efficient use of energy helps reduce our carbon footprint. Smart home devices can help us manage our energy usage better. Smart home devices can help us manage our energy usage better. Renewable energy sources like solar and wind power are the future. Renewable energy sources like solar and wind power are the future. Insulating our homes keeps them cozy and saves energy too. Insulating our homes keeps them cozy and saves energy too. Energy-efficient appliances last longer and use less power. Energy-efficient appliances last longer and use less power. Green buildings are designed to be environmentally friendly and efficient. Green buildings are designed to be environmentally friendly and efficient.
Water displacement occurs when an object is fully submerged. Water displacement occurs when an object is fully submerged. The volume of water displaced is equal to the volume of the submerged object. The volume of water displaced is equal to the volume of the submerged object. Buoyant force acts upward on an object immersed in a fluid. Buoyant force acts upward on an object immersed in a fluid. Fluid pressure increases with depth due to gravity's effect. Fluid pressure increases with depth due to gravity's effect. The principle applies to all fluids, including water and air. The principle applies to all fluids, including water and air. Objects experience upthrust when partially or fully submerged. Objects experience upthrust when partially or fully submerged. Weight displacement relates directly to the density of the surrounding liquid. Weight displacement relates directly to the density of the surrounding liquid.
Water boils at 100 degrees Celsius. Water boils at 100 degrees Celsius. Heat is energy transferred from one object to another. Heat is energy transferred from one object to another. Temperature measures how hot or cold something is. Temperature measures how hot or cold something is. The thermometer read 25 degrees Celsius outside today. The thermometer read 25 degrees Celsius outside today. Heat flows from a hotter object to a cooler one. Heat flows from a hotter object to a cooler one. Temperature is measured in units like Celsius or Fahrenheit. Temperature is measured in units like Celsius or Fahrenheit. Heat can be transferred through conduction, radiation, or convection. Heat can be transferred through conduction, radiation, or convection.
An object has potential energy if raised high above the ground. An object has potential energy if raised high above the ground. Potential energy is stored due to an object's position. Potential energy is stored due to an object's position. A compressed spring gains potential energy. A compressed spring gains potential energy. A ball at the top of a hill has potential energy ready to be released. A ball at the top of a hill has potential energy ready to be released. An object gains potential energy as it rises off the ground. An object gains potential energy as it rises off the ground. Compressed air in a tank has potential energy for work. Compressed air in a tank has potential energy for work. The height of an object is directly related to its potential energy. The height of an object is directly related to its potential energy.
Hold your fingers together, palm facing north. Hold your fingers together, palm facing north. Point your thumb away from the current flow. Point your thumb away from the current flow. Your fingers will curl into a circle, showing the field direction. Your fingers will curl into a circle, showing the field direction. The magnetic field lines point from south to north. The magnetic field lines point from south to north. Keep your hand in the same orientation as the current loop. Keep your hand in the same orientation as the current loop. Check that your thumb is opposite to the arrow's head. Check that your thumb is opposite to the arrow's head. Now curl your fingers to find the direction of the force. Now curl your fingers to find the direction of the force. The magnetic field lines are perpendicular to the plane of the wire. The magnetic field lines are perpendicular to the plane of the wire. Make sure your palm faces towards the compass needle. Make sure your palm faces towards the compass needle. The right-hand rule helps us visualize the magnetic field correctly. The right-hand rule helps us visualize the magnetic field correctly.
Constructive interference adds up waves. Constructive interference adds up waves. Destructive interference cancels out waves. Destructive interference cancels out waves. Waves combine to create a stronger signal. Waves combine to create a stronger signal. The peaks align for constructive interference. The peaks align for constructive interference.
Interference patterns form in the resulting wave. Interference patterns form in the resulting wave. This creates a more intense or loud sound. This creates a more intense or loud sound.
In contrast, waves cancel each other out completely. In contrast, waves cancel each other out completely. Resulting wave is either amplified or extinguished. Resulting wave is either amplified or extinguished.
Energy is transferred from one place to another. Energy is transferred from one place to another. Waves can move energy across long distances. Waves can move energy across long distances. The sun's energy is transferred through light waves. The sun's energy is transferred through light waves.
Water molecules transfer energy as a wave moves. Water molecules transfer energy as a wave moves.
Mechanical energy is converted into electrical energy. Mechanical energy is converted into electrical energy. Some of the energy in waves is lost to heat or friction. Some of the energy in waves is lost to heat or friction. Transfer of energy allows for communication over long distances. Transfer of energy allows for communication over long distances. Energy transfer occurs through electromagnetic forces as well. Energy transfer occurs through electromagnetic forces as well.
Gravity always pulls objects towards each other. Gravity always pulls objects towards each other. The Earth's mass affects the force of gravity on an object. The Earth's mass affects the force of gravity on an object. Mass and weight are related but not exactly the same thing. Mass and weight are related but not exactly the same thing. Forces like friction can slow down an object's movement. Forces like friction can slow down an object's movement. Energy is transferred when one object moves another. Energy is transferred when one object moves another. Potential energy is stored in objects due to their height or position. Potential energy is stored in objects due to their height or position. Gravitational potential energy depends on mass gravity and height. Gravitational potential energy depends on mass gravity and height. Objects at higher elevations have more gravitational potential energy. Objects at higher elevations have more gravitational potential energy. Gravity's force gets weaker with increasing distance from the Earth. Gravity's force gets weaker with increasing distance from the Earth.
Friction helps prevent slipping and ensures grip. Friction helps prevent slipping and ensures grip. Friction is necessary for braking systems to function. Friction is necessary for braking systems to function. Friction keeps wheels from rolling away when stationary. Friction keeps wheels from rolling away when stationary. Friction prevents engines from seizing up. Friction prevents engines from seizing up. Friction supports the transmission of forces between surfaces. Friction supports the transmission of forces between surfaces. Friction helps maintain traction on slippery surfaces. Friction helps maintain traction on slippery surfaces. Friction prevents gears from getting stuck together. Friction prevents gears from getting stuck together. Friction aids in the creation of secure mechanical connections. Friction aids in the creation of secure mechanical connections. Friction plays a key role in the operation of clutches. Friction plays a key role in the operation of clutches.
Quantum mechanics studies tiny particles. Quantum mechanics studies tiny particles. These particles are the building blocks of everything. These particles are the building blocks of everything.
Energy in quantum mechanics comes in packets called quanta. Energy in quantum mechanics comes in packets called quanta.
The position and momentum of a particle cannot both be precisely known. The position and momentum of a particle cannot both be precisely known. Measuring one property creates uncertainty in the other. Measuring one property creates uncertainty in the other. Quantum mechanics uses probabilities, not definite outcomes. Quantum mechanics uses probabilities, not definite outcomes. Particles can exist in multiple states at once. Particles can exist in multiple states at once. Superposition is key to quantum behavior. Superposition is key to quantum behavior. Quantum entanglement links particles correlating their properties. Quantum entanglement links particles correlating their properties. Entangled particles can affect each other instantly, even at a distance. Entangled particles can affect each other instantly, even at a distance.
Radioactive materials decay at a steady rate. Radioactive materials decay at a steady rate.
Alpha particles have a positive charge. Alpha particles have a positive charge. Beta particles can travel long distances. Beta particles can travel long distances. Uranium is a highly radioactive element. Uranium is a highly radioactive element. Radioactive decay is a random process. Radioactive decay is a random process. Gamma radiation has no mass or charge. Gamma radiation has no mass or charge. Nuclear reactions release a lot of energy. Nuclear reactions release a lot of energy. Radioactive materials can be hazardous to health. Radioactive materials can be hazardous to health. Neutrons are neutral particles that can penetrate material. Neutrons are neutral particles that can penetrate material. Half-life is the time it takes for radiation to decrease by half. Half-life is the time it takes for radiation to decrease by half.
Light can behave like a particle. Light can behave like a particle. Photons have both wave-like and particle-like properties. Photons have both wave-like and particle-like properties. The act of observing particles influences their behavior. The act of observing particles influences their behavior. Some experiments show light behaving as a wave. Some experiments show light behaving as a wave. Wave-particle duality is observed in electrons too. Wave-particle duality is observed in electrons too. Electrons can exhibit characteristics of both waves and particles. Electrons can exhibit characteristics of both waves and particles. Quantum mechanics helps us understand this phenomenon. Quantum mechanics helps us understand this phenomenon. The behavior of subatomic particles is probabilistic, not definite. The behavior of subatomic particles is probabilistic, not definite.
Wave-particle duality challenges classical notions of reality. Wave-particle duality challenges classical notions of reality.
Observations reveal the dual nature of all particles and waves. Observations reveal the dual nature of all particles and waves.
Atoms are the building blocks of matter. Atoms are the building blocks of matter. Matter is everything around us. Matter is everything around us. Atoms consist of electrons, protons, and neutrons. Atoms consist of electrons, protons, and neutrons. Protons have a positive charge. Protons have a positive charge. Electrons have a negative charge. Electrons have a negative charge. Neutrons have no charge. Neutrons have no charge. The number of protons in an atom determines its identity. The number of protons in an atom determines its identity. Atoms can be bonded to form molecules. Atoms can be bonded to form molecules. Molecules are made up of multiple atoms. Molecules are made up of multiple atoms. At the atomic level, everything is made of tiny particles. At the atomic level, everything is made of tiny particles.
Identify all given information and what needs to be found. Identify all given information and what needs to be found. Draw a diagram to visualize the problem. Draw a diagram to visualize the problem. Label all known lengths, angles, and points. Label all known lengths, angles, and points. Apply relevant theorems or formulas. Apply relevant theorems or formulas. Break the problem into smaller, solvable parts. Break the problem into smaller, solvable parts. Use symmetry or congruent shapes to simplify calculations. Use symmetry or congruent shapes to simplify calculations. Check for right angles or parallel lines that can help solve the problem. Check for right angles or parallel lines that can help solve the problem.
Convert units if necessary to ensure consistency. Convert units if necessary to ensure consistency.
Use trigonometric ratios for angle-related problems. Use trigonometric ratios for angle-related problems.
Verify your solution by ensuring all geometric properties are satisfied. Verify your solution by ensuring all geometric properties are satisfied.
Black bodies emit radiation. Black bodies emit radiation. All bodies radiate heat. All bodies radiate heat. The energy emitted increases with temperature. The energy emitted increases with temperature. Radiation is a form of energy transfer. Radiation is a form of energy transfer. Peak emission occurs at specific wavelengths. Peak emission occurs at specific wavelengths. Temperature affects the frequency distribution. Temperature affects the frequency distribution. Higher temperatures produce more intense radiation. Higher temperatures produce more intense radiation. Blackbody radiation demonstrates thermal equilibrium principle. Blackbody radiation demonstrates thermal equilibrium principle.
Hydrogen is the lightest element. Hydrogen is the lightest element. Atomic nuclei are held together by the strong force. Atomic nuclei are held together by the strong force. Electrons occupy specific energy levels around an atom. Electrons occupy specific energy levels around an atom. The number of protons determines an element's identity. The number of protons determines an element's identity. Radioactive decay releases radiation into the environment. Radioactive decay releases radiation into the environment. Nuclear reactions require a nucleus to be split or combined. Nuclear reactions require a nucleus to be split or combined. Particle accelerators accelerate charged particles to high speeds. Particle accelerators accelerate charged particles to high speeds. The strong force acts over very short distances, not like gravity. The strong force acts over very short distances, not like gravity. Charged particles interact with electromagnetic fields. Charged particles interact with electromagnetic fields. Energy is released when nuclear reactions occur. Energy is released when nuclear reactions occur.
Astronomers have found a new exoplanet orbiting a nearby star. Astronomers have found a new exoplanet orbiting a nearby star. Scientists detected gravitational waves from merging neutron stars. Scientists detected gravitational waves from merging neutron stars. Researchers identified a massive galaxy in the distant universe. Researchers identified a massive galaxy in the distant universe. Hubble observed a supernova exploding in a nearby galaxy. Hubble observed a supernova exploding in a nearby galaxy. Water vapor was found on a potentially habitable exoplanet. Water vapor was found on a potentially habitable exoplanet. Astronomers mapped the Sun's magnetic field with high precision. Astronomers mapped the Sun's magnetic field with high precision. Scientists discovered a star that's both hot and cool. Scientists discovered a star that's both hot and cool. James Webb detected the most distant stars ever observed. James Webb detected the most distant stars ever observed. Researchers identified a massive structure in the cosmic web. Researchers identified a massive structure in the cosmic web.
The nucleus is at the center of an atom. The nucleus is at the center of an atom. Electrons orbit around the nucleus in circular paths. Electrons orbit around the nucleus in circular paths. These paths are called energy levels or shells. These paths are called energy levels or shells. Each shell can hold a specific number of electrons. Each shell can hold a specific number of electrons. The electrons in each shell have the same energy level. The electrons in each shell have the same energy level. The Bohr model shows that electron movement is quantized. The Bohr model shows that electron movement is quantized. Electrons jump to higher energy levels when heated. Electrons jump to higher energy levels when heated. When heated, electrons absorb and emit specific wavelengths of light. When heated, electrons absorb and emit specific wavelengths of light. The Bohr model accurately predicted atomic spectra and behavior. The Bohr model accurately predicted atomic spectra and behavior. It was a significant improvement over earlier atomic theories. It was a significant improvement over earlier atomic theories.
Electricity is all around us. Electricity is all around us. Lightning is a form of electricity. Lightning is a form of electricity. Conductors carry electricity well. Conductors carry electricity well. Insulators stop the flow of electricity. Insulators stop the flow of electricity. Wires have to be connected for electricity to flow. Wires have to be connected for electricity to flow. A circuit is a loop of electricity. A circuit is a loop of electricity. Electricity can be generated from water or steam. Electricity can be generated from water or steam. The voltage measures how strong the electricity is. The voltage measures how strong the electricity is. Current flows in one direction always. Current flows in one direction always. Electrical energy powers many devices and machines. Electrical energy powers many devices and machines.
The atom is made up of a tiny dense center called the nucleus. The atom is made up of a tiny dense center called the nucleus. Protons and neutrons are found inside the atomic nucleus. Protons and neutrons are found inside the atomic nucleus. The nucleus is positively charged due to its protons. The nucleus is positively charged due to its protons. Neutrons have no charge but still reside in the nucleus. Neutrons have no charge but still reside in the nucleus. The atomic nucleus is incredibly small compared to the atom itself. The atomic nucleus is incredibly small compared to the atom itself. Electrons orbit around the nucleus at high speeds. Electrons orbit around the nucleus at high speeds. The nucleus plays a crucial role in determining an element's properties. The nucleus plays a crucial role in determining an element's properties.
The universe is vast and mysterious. The universe is vast and mysterious. Dark matter exists beyond a doubt. Dark matter exists beyond a doubt. Black holes hold secrets we're still uncovering. Black holes hold secrets we're still uncovering. Time has a beginning, but no end. Time has a beginning, but no end. The multiverse is likely a reality. The multiverse is likely a reality. Gravity warps space in profound ways. Gravity warps space in profound ways. Stars are born and die with regularity. Stars are born and die with regularity. Planets orbit around stars by design. Planets orbit around stars by design. The Big Bang is the origin of our universe. The Big Bang is the origin of our universe. The cosmos have a hidden beauty that we're discovering. The cosmos have a hidden beauty that we're discovering.
Identify the potential barrier. Identify the potential barrier. Determine the energy of the particle. Determine the energy of the particle. Solve the Schrödinger equation inside the barrier. Solve the Schrödinger equation inside the barrier. Calculate the transmission coefficient. Calculate the transmission coefficient.
Use the wave function continuity conditions. Use the wave function continuity conditions.
Apply the decay rate inside the barrier. Apply the decay rate inside the barrier.
Determine the wave function outside the barrier. Determine the wave function outside the barrier.
Compute the tunneling probability. Compute the tunneling probability. Express the probability as a function of barrier width. Express the probability as a function of barrier width. Compare with classical predictions. Compare with classical predictions.
Electromagnetic waves have no mass. Electromagnetic waves have no mass. They travel at the speed of light. They travel at the speed of light. All electromagnetic waves are vibrations. All electromagnetic waves are vibrations. Radio waves have long wavelengths. Radio waves have long wavelengths. Microwaves are used for heating food. Microwaves are used for heating food. Visible light can pass through water. Visible light can pass through water. Ultraviolet rays cause sunburns. Ultraviolet rays cause sunburns. X-rays can be used to see inside the body. X-rays can be used to see inside the body. Gamma rays have high energy levels. Gamma rays have high energy levels.
Atoms split into smaller parts. Atoms split into smaller parts. Nucleus breaks apart from surrounding material. Nucleus breaks apart from surrounding material. Energy is released as a byproduct. Energy is released as a byproduct. Fission occurs when atomic nuclei collide. Fission occurs when atomic nuclei collide. Radioactive isotopes are produced in the process. Radioactive isotopes are produced in the process. Heavy elements split into lighter ones. Heavy elements split into lighter ones. A chain reaction can form if conditions are right. A chain reaction can form if conditions are right. Control rods regulate the rate of fission. Control rods regulate the rate of fission. Neutrons are released as a result of fission. Neutrons are released as a result of fission. Fission is used in nuclear reactors and bombs. Fission is used in nuclear reactors and bombs.
Quantum entanglement is a real phenomenon. Quantum entanglement is a real phenomenon. Entangled particles can be used for instant communication. Entangled particles can be used for instant communication. Superposition and entanglement are key to quantum computing. Superposition and entanglement are key to quantum computing. The Napier paradox highlights the weirdness of entanglement. The Napier paradox highlights the weirdness of entanglement. Quantum entanglement has no explanation in classical physics. Quantum entanglement has no explanation in classical physics. Entangled particles can be separated by arbitrary distances. Entangled particles can be separated by arbitrary distances. Measurement of one particle collapses the state of another. Measurement of one particle collapses the state of another. Quantum entanglement is a fundamental aspect of reality. Quantum entanglement is a fundamental aspect of reality. Entanglement is essential for quantum teleportation to work. Entanglement is essential for quantum teleportation to work.
Quantum computers can solve complex problems quickly. Quantum computers can solve complex problems quickly. Simulations using quantum computers are already being done. Simulations using quantum computers are already being done. Quantum computing has vast potential applications. Quantum computing has vast potential applications. Quantum computers use qubits instead of regular bits. Quantum computers use qubits instead of regular bits. Entangled particles are a key feature of quantum computing. Entangled particles are a key feature of quantum computing. Quantum algorithms can break certain types of encryption. Quantum algorithms can break certain types of encryption. The development of practical quantum computers is underway. The development of practical quantum computers is underway. Companies like Google and IBM are investing in quantum tech. Companies like Google and IBM are investing in quantum tech. Quantum computing has the potential to revolutionize industries. Quantum computing has the potential to revolutionize industries.
The Standard Model cannot account for dark matter. The Standard Model cannot account for dark matter. There is no explanation for neutrino masses in the Standard Model. There is no explanation for neutrino masses in the Standard Model. The model ignores gravitational interactions entirely. The model ignores gravitational interactions entirely. It doesn't address the issue of CP symmetry breaking. It doesn't address the issue of CP symmetry breaking. The Standard Model cannot predict the matter-antimatter asymmetry. The Standard Model cannot predict the matter-antimatter asymmetry. There's no room for non-abelian gauge symmetries in this model. There's no room for non-abelian gauge symmetries in this model. The Standard Model has no provision for a fourth generation of fermions. The Standard Model has no provision for a fourth generation of fermions. The model relies on fine-tuning to explain the Higgs mass. The model relies on fine-tuning to explain the Higgs mass.
String theory explains fundamental forces consistently. String theory explains fundamental forces consistently. The math behind string theory has been validated through models. The math behind string theory has been validated through models. String theory delivers a description of quantum gravity. String theory delivers a description of quantum gravity. String theory helps explore solutions to quantum gravity problems. String theory helps explore solutions to quantum gravity problems.
No empirical evidence supports alternate universes. No empirical evidence supports alternate universes. The multiverse idea oversimplifies quantum mechanics and cosmology. The multiverse idea oversimplifies quantum mechanics and cosmology. There is no logical need for alternate realities beyond our own. There is no logical need for alternate realities beyond our own. Many problems can be solved without invoking the multiverse. Many problems can be solved without invoking the multiverse. We can't test hypotheses about parallel universes outside our reality. We can't test hypotheses about parallel universes outside our reality.
Galactic rotation curves show a constant velocity at large distances. Galactic rotation curves show a constant velocity at large distances. Dark matter is not just a theoretical concept, but an observational fact. Dark matter is not just a theoretical concept, but an observational fact.
Gravitational waves help us study cosmic events. Gravitational waves help us study cosmic events. They reveal black hole mergers. They reveal black hole mergers. Binary star systems emit detectable gravitational waves. Binary star systems emit detectable gravitational waves. These ripples confirm Einstein's theory. These ripples confirm Einstein's theory. Gravitational wave observations expand our understanding of cosmic history. Gravitational wave observations expand our understanding of cosmic history. They provide a new way to study the universe. They provide a new way to study the universe. Gravitational waves have opened a new field of research. Gravitational waves have opened a new field of research. These waves confirm general relativity predictions. These waves confirm general relativity predictions. Cosmic ripples carry information about energetic events. Cosmic ripples carry information about energetic events.
Observing a particle changes its behavior. Observing a particle changes its behavior. Wave-particle duality is a fundamental aspect of reality. Wave-particle duality is a fundamental aspect of reality. The wave-particle distinction is a human construct. The wave-particle distinction is a human construct. Measurement is an active participant in the physical world. Measurement is an active participant in the physical world. Wave-particle duality challenges traditional views of space and time. Wave-particle duality challenges traditional views of space and time. Our understanding of reality requires wave-particle duality. Our understanding of reality requires wave-particle duality. The uncertainty principle stems from wave-like behavior. The uncertainty principle stems from wave-like behavior. Wave-particle duality impacts our views on free will and determinism. Wave-particle duality impacts our views on free will and determinism.
AI can offer new insights into complex physical systems. AI can offer new insights into complex physical systems. Machine learning accelerates our understanding of quantum mechanics. Machine learning accelerates our understanding of quantum mechanics. AI will revolutionize mathematical modeling in physics. AI will revolutionize mathematical modeling in physics. Deep learning may reveal hidden patterns in particle collision data. Deep learning may reveal hidden patterns in particle collision data. Machine learning helps identify meaningful features in large datasets. Machine learning helps identify meaningful features in large datasets. AI methods will improve our understanding of black hole behavior. AI methods will improve our understanding of black hole behavior. AI will be key to solving mysteries of dark matter and dark energy. AI will be key to solving mysteries of dark matter and dark energy.
Symmetry plays a crucial role in modern physics. Symmetry plays a crucial role in modern physics. The laws of physics remain unchanged under rotation. The laws of physics remain unchanged under rotation. Spatial symmetry is essential for quantum mechanics. Spatial symmetry is essential for quantum mechanics. Time reversal symmetry is broken at the quantum level. Time reversal symmetry is broken at the quantum level. Electromagnetic gauge symmetry unifies electric and magnetic forces. Electromagnetic gauge symmetry unifies electric and magnetic forces. Symmetry dictates the behavior of subatomic particles. Symmetry dictates the behavior of subatomic particles. Broken symmetry explains the origin of mass in the universe. Broken symmetry explains the origin of mass in the universe. Isospin symmetry is a fundamental property of hadrons. Isospin symmetry is a fundamental property of hadrons. Internal symmetry governs particle interactions at high energies. Internal symmetry governs particle interactions at high energies.
Experimental evidence is crucial to validate theoretical claims. Experimental evidence is crucial to validate theoretical claims. Verification through experimentation drives scientific progress. Verification through experimentation drives scientific progress. Observations confirm the accuracy of a theory. Observations confirm the accuracy of a theory. Theories without proof are mere speculation. Theories without proof are mere speculation. Experimentation provides the highest level of scientific evidence. Experimentation provides the highest level of scientific evidence. Hands-on testing ensures the validity of physical principles. Hands-on testing ensures the validity of physical principles. Data-driven verification defines scientific inquiry. Data-driven verification defines scientific inquiry. Experimentation proves or disproves a hypothesis. Experimentation proves or disproves a hypothesis. Scientific theories must be supported by empirical evidence. Scientific theories must be supported by empirical evidence. Experimental confirmation is key to establishing physical laws. Experimental confirmation is key to establishing physical laws.
It's impossible to exceed light speed. It's impossible to exceed light speed. FDL travel defies our understanding of space-time. FDL travel defies our understanding of space-time. The universe has no shortcuts for us to take. The universe has no shortcuts for us to take. We're stuck with the laws of physics as they are. We're stuck with the laws of physics as they are. No technology can break the light barrier. No technology can break the light barrier. FDL travel is a scientific impossibility. FDL travel is a scientific impossibility. We must respect the speed limit imposed by Einstein. We must respect the speed limit imposed by Einstein. The universe has its own pace and we're bound to it. The universe has its own pace and we're bound to it. Our fastest ships will never outrun light itself. Our fastest ships will never outrun light itself. FDL travel contradicts everything we know about physics. FDL travel contradicts everything we know about physics.
The photoelectric effect shows light's particle-like behavior. The photoelectric effect shows light's particle-like behavior. Light can eject electrons from a metal without raising its temperature. Light can eject electrons from a metal without raising its temperature. Photons transfer energy to a material regardless of its initial state. Photons transfer energy to a material regardless of its initial state. The speed of ejected electrons doesn't depend on light intensity. The speed of ejected electrons doesn't depend on light intensity. Increasing light frequency raises the kinetic energy of emitted electrons. Increasing light frequency raises the kinetic energy of emitted electrons. A material's ability to emit electrons is a key property. A material's ability to emit electrons is a key property. The threshold frequency for electron emission varies by material. The threshold frequency for electron emission varies by material. Quantum theory accurately predicts photoelectric effect outcomes. Quantum theory accurately predicts photoelectric effect outcomes.
The Copenhagen interpretation doesn't explain wave function collapse. The Copenhagen interpretation doesn't explain wave function collapse. Quantum mechanics needs measurement outcomes to be fully understood. Quantum mechanics needs measurement outcomes to be fully understood. It assumes a random, uncontrolled process in quantum systems. It assumes a random, uncontrolled process in quantum systems. Wave function collapse isn't essential to quantum mechanics. Wave function collapse isn't essential to quantum mechanics. Measurement unpredictably affects a quantum system's state. Measurement unpredictably affects a quantum system's state. Quantum systems have probabilities, not definite outcomes. Quantum systems have probabilities, not definite outcomes. The Copenhagen interpretation over-relies on human perception. The Copenhagen interpretation over-relies on human perception. Randomness is central to quantum mechanics. Randomness is central to quantum mechanics. Copenhagen doesn't address observer-induced non-locality effects. Copenhagen doesn't address observer-induced non-locality effects.
Dark matter is not supported by recent observations. Dark matter is not supported by recent observations. Modified gravity theories have gained significant traction. Modified gravity theories have gained significant traction. Brain cosmology offers an attractive alternative scenario. Brain cosmology offers an attractive alternative scenario. Quantum gravity effects may be responsible for the acceleration. Quantum gravity effects may be responsible for the acceleration. The vacuum energy density is surprisingly small. The vacuum energy density is surprisingly small. Scalar field models are being actively explored. Scalar field models are being actively explored. Torsion theories have been shown to be a viable option. Torsion theories have been shown to be a viable option. Bouncing cosmology presents an interesting alternative paradigm. Bouncing cosmology presents an interesting alternative paradigm.
The universe had to be just right for life to exist. The universe had to be just right for life to exist. Our existence requires a certain order in the cosmos. Our existence requires a certain order in the cosmos. The laws of physics must be suitable for conscious beings. The laws of physics must be suitable for conscious beings. Life demands specific conditions to flourish. Life demands specific conditions to flourish. The anthropic principle suggests we are living in the right time. The anthropic principle suggests we are living in the right time. Consciousness requires a universe with particular properties. Consciousness requires a universe with particular properties. Our reality is optimized for intelligent life forms. Our reality is optimized for intelligent life forms. The cosmos must be arranged in a way that allows us to exist. The cosmos must be arranged in a way that allows us to exist. We owe our existence to the delicate balance of the universe. We owe our existence to the delicate balance of the universe. Life's emergence relies on a specific set of cosmological conditions. Life's emergence relies on a specific set of cosmological conditions.
Write down the Hamiltonian of the system. Write down the Hamiltonian of the system. Identify the perturbation term. Identify the perturbation term.
Calculate the unperturbed wave functions. Calculate the unperturbed wave functions.
Use the matrix elements of the perturbation. Use the matrix elements of the perturbation. Set up the first-order perturbation integral. Set up the first-order perturbation integral. Evaluate the matrix elements for the initial and final states. Evaluate the matrix elements for the initial and final states. Compute the transition probability. Compute the transition probability. Apply the Born approximation for weak perturbations. Apply the Born approximation for weak perturbations.
Sum over all possible final states. Sum over all possible final states.
Compare the result with experimental data. Compare the result with experimental data.
Particle accelerators drive human innovation. Particle accelerators drive human innovation. Understanding subatomic particles is crucial for future tech. Understanding subatomic particles is crucial for future tech. Particle physics informs our understanding of the universe's structure. Particle physics informs our understanding of the universe's structure. Accelerator research has led to advances in materials science. Accelerator research has led to advances in materials science. Studying subatomic particles helps us understand matter's properties. Studying subatomic particles helps us understand matter's properties. Particle accelerators accelerate scientific discovery and progress. Particle accelerators accelerate scientific discovery and progress. Fundamental physics discoveries from accelerators benefit society broadly. Fundamental physics discoveries from accelerators benefit society broadly. Accelerator research informs our understanding of the cosmos evolution. Accelerator research informs our understanding of the cosmos evolution.
Models fail to explain lithium abundance. Models fail to explain lithium abundance. Deuterium rates are overestimated. Deuterium rates are overestimated. Neutrinos' role in element synthesis is ignored. Neutrinos' role in element synthesis is ignored. Magnetic fields' impact on reactions is neglected. Magnetic fields' impact on reactions is neglected. Standard models misrepresent nucleosynthesis. Standard models misrepresent nucleosynthesis. Models overlook nuclear cosmological interactions. Models overlook nuclear cosmological interactions. Big Bang nucleosynthesis models need revision. Big Bang nucleosynthesis models need revision.
Private investment is key for space exploration progress. Private investment is key for space exploration progress. Gravity models will be proven by future experiments. Gravity models will be proven by future experiments. Space-time research will transform our understanding of the universe. Space-time research will transform our understanding of the universe. AI will play a major role in mission planning. AI will play a major role in mission planning. Space-time discoveries will impact physics theory. Space-time discoveries will impact physics theory. Increased funding is vital for research advancement. Increased funding is vital for research advancement. Space telescopes will observe dark matter. Space telescopes will observe dark matter. Quantum gravity theories will be tested soon. Quantum gravity theories will be tested soon. The next decade will bring a paradigm shift in space-time research. The next decade will bring a paradigm shift in space-time research.
Black holes are key to galaxy formation. Black holes are key to galaxy formation. They control star formation by regulating gas supply. They control star formation by regulating gas supply. Supermassive black holes are at galaxy centers. Supermassive black holes are at galaxy centers. Black hole growth is tied to galaxy evolution. Black hole growth is tied to galaxy evolution. Their gravity affects nearby star formation and planet migration. Their gravity affects nearby star formation and planet migration. The event horizon influences the interstellar medium. The event horizon influences the interstellar medium. Galaxy morphology changes with black hole activity. Galaxy morphology changes with black hole activity. Central black holes regulate the gas-fueling galaxy growth. Central black holes regulate the gas-fueling galaxy growth.
Identify whether the problem involves differentiation or integration. Identify whether the problem involves differentiation or integration. Apply the chain rule for composite functions. Apply the chain rule for composite functions. Use substitution to simplify integrals. Use substitution to simplify integrals. Break down complex functions into simpler parts. Break down complex functions into simpler parts. Apply limits to evaluate indeterminate forms. Apply limits to evaluate indeterminate forms. Use the power rule for basic differentiation. Use the power rule for basic differentiation. Check for continuity and differentiability before applying rules. Check for continuity and differentiability before applying rules. Apply the fundamental theorem of calculus for definite integrals. Apply the fundamental theorem of calculus for definite integrals. Use partial fractions to simplify complex integrals. Use partial fractions to simplify complex integrals. Verify your solution by differentiating or integrating back. Verify your solution by differentiating or integrating back.
Neutrinos reveal secrets of the universe's creation. Neutrinos reveal secrets of the universe's creation. Understanding neutrinos is key to dark matter mysteries. Understanding neutrinos is key to dark matter mysteries. Neutrino research has led to breakthroughs in particle physics. Neutrino research has led to breakthroughs in particle physics. Neutrinos have changed our understanding of fundamental forces. Neutrinos have changed our understanding of fundamental forces. Investing in neutrinos will drive major breakthroughs in physics. Investing in neutrinos will drive major breakthroughs in physics. Neutrinos help explain cosmic ray and supernova phenomena. Neutrinos help explain cosmic ray and supernova phenomena. Neutrino research is crucial for understanding the universe. Neutrino research is crucial for understanding the universe. Neutrino detection has led to innovations beyond physics. Neutrino detection has led to innovations beyond physics. Supporting neutrino research advances our knowledge of matter and energy. Supporting neutrino research advances our knowledge of matter and energy. Continued neutrino study will shift our understanding of the cosmos. Continued neutrino study will shift our understanding of the cosmos.
Time is an inherent feature of the cosmos. Time is an inherent feature of the cosmos. The passage of time is universally observable. The passage of time is universally observable. Time is an absolute necessity for causality to exist. Time is an absolute necessity for causality to exist. Every event in the universe is time-stamped by its temporal occurrence. Every event in the universe is time-stamped by its temporal occurrence. The laws of physics are temporally dependent and therefore time-bound. The laws of physics are temporally dependent and therefore time-bound. All physical processes occur with an intrinsic temporal structure. All physical processes occur with an intrinsic temporal structure. Time is essential for the evolution and development of complex systems. Time is essential for the evolution and development of complex systems. The fabric of spacetime is woven together by its temporal threads. The fabric of spacetime is woven together by its temporal threads.
Quantum effects are negligible at large scales. Quantum effects are negligible at large scales. Gravity is not a quantum phenomenon. Gravity is not a quantum phenomenon. The laws of physics work just fine without a unified theory. The laws of physics work just fine without a unified theory. Unification might be too mathematically complicated to achieve. Unification might be too mathematically complicated to achieve. Quantum mechanics is complete as it stands. Quantum mechanics is complete as it stands. General relativity is sufficient for astrophysical applications. General relativity is sufficient for astrophysical applications. A unified theory may never be necessary or useful. A unified theory may never be necessary or useful. Quantum gravity can wait until more pressing scientific issues are resolved. Quantum gravity can wait until more pressing scientific issues are resolved.
Mathematical elegance guides physical truth. Mathematical elegance guides physical truth. Beauty and simplicity reflect profound insight. Beauty and simplicity reflect profound insight. Theoretical physics values mathematical harmony. Theoretical physics values mathematical harmony. Mathematical beauty leads to revolutionary discoveries. Mathematical beauty leads to revolutionary discoveries. Symmetry, elegance, and precision define good theories. Symmetry, elegance, and precision define good theories. Physical laws should be expressed by beautiful mathematics. Physical laws should be expressed by beautiful mathematics. The pursuit of beauty drives major advances in understanding. The pursuit of beauty drives major advances in understanding. Mathematically beautiful theory is more likely to be correct. Mathematically beautiful theory is more likely to be correct. Mathematical elegance uncovers hidden symmetries in systems. Mathematical elegance uncovers hidden symmetries in systems. Beautiful mathematics often indicates deeper understanding. Beautiful mathematics often indicates deeper understanding.
Parallel universes can be detected via cosmological observations. Parallel universes can be detected via cosmological observations. The multiverse hypothesis predicts experimental evidence. The multiverse hypothesis predicts experimental evidence. Indirect signs of parallel universes will emerge in a decade. Indirect signs of parallel universes will emerge in a decade. Methods to detect the multiverse are under development. Methods to detect the multiverse are under development. Parallel universes can be probed with high-energy particle collisions. Parallel universes can be probed with high-energy particle collisions. Investing in multiverse research is essential. Investing in multiverse research is essential. Black holes may reveal secrets of parallel universes. Black holes may reveal secrets of parallel universes. Experimental proof of the multiverse will transform physics. Experimental proof of the multiverse will transform physics. Parallel universes are a logical consequence of certain theories. Parallel universes are a logical consequence of certain theories. Top physicists are exploring methods to detect parallel universes. Top physicists are exploring methods to detect parallel universes.
The data shows a clear enhancement of the resonance. The data shows a clear enhancement of the resonance. Our measurements confirm the predicted interaction rates. Our measurements confirm the predicted interaction rates. We observe a strong correlation between the two particle types. We observe a strong correlation between the two particle types. The analysis reveals a previously unknown decay mode. The analysis reveals a previously unknown decay mode. Our team's experimental design proves to be highly effective. Our team's experimental design proves to be highly effective. We detect a substantial increase in cross-sections for this reaction. We detect a substantial increase in cross-sections for this reaction. The collaborative effort yields valuable new insights into nuclear forces. The collaborative effort yields valuable new insights into nuclear forces.
The model accurately captures binary system dynamics. The model accurately captures binary system dynamics. The research sheds new light on galaxy formation and evolution. The research sheds new light on galaxy formation and evolution. The conclusions align with existing literature. The conclusions align with existing literature. The simulations agree well with observational results. The simulations agree well with observational results. The paper reviews recent advances in stellar evolution theory. The paper reviews recent advances in stellar evolution theory. The methodology is well justified and transparent. The methodology is well justified and transparent. The findings have implications for dark matter properties. The findings have implications for dark matter properties. The paper significantly advances resolving the discrepancy. The paper significantly advances resolving the discrepancy. The results align with theoretical predictions and observations. The results align with theoretical predictions and observations.
The experimental results match the theoretical predictions. The experimental results match the theoretical predictions. Quantum entanglement is a well-established phenomenon. Quantum entanglement is a well-established phenomenon. The author's use of perturbation theory was justified. The author's use of perturbation theory was justified. The paper provides a clear and concise overview of the subject. The paper provides a clear and concise overview of the subject.
The data analysis techniques used are sound. The data analysis techniques used are sound.
The implications of the findings are far-reaching. The implications of the findings are far-reaching. The model accurately reproduces the observed behavior. The model accurately reproduces the observed behavior. The discussion section is well-written and informative. The discussion section is well-written and informative. The use of advanced numerical methods was effective. The use of advanced numerical methods was effective. The conclusions drawn from the data are reasonable. The conclusions drawn from the data are reasonable.
Entropy is disorder that grows over time. Entropy is disorder that grows over time. Shuffling a deck increases entropy, making it less organized. Shuffling a deck increases entropy, making it less organized. Entropy is like a pile of laundry that keeps growing. Entropy is like a pile of laundry that keeps growing. In a closed system, entropy increases as things get more chaotic. In a closed system, entropy increases as things get more chaotic. Entropy is like a Jenga tower that becomes unstable with every move. Entropy is like a Jenga tower that becomes unstable with every move. As coffee cools, its entropy increases as molecules spread out. As coffee cools, its entropy increases as molecules spread out. Entropy is like a library where books are misplaced and hard to find. Entropy is like a library where books are misplaced and hard to find. Entropy reflects the number of possible ways particles can be arranged. Entropy reflects the number of possible ways particles can be arranged. Entropy increases when a sculpture is reduced to random pieces. Entropy increases when a sculpture is reduced to random pieces.
Write the total Hamiltonian for the system. Write the total Hamiltonian for the system. Identify the scattering potential. Identify the scattering potential. Set up the wave function for the incoming and outgoing states. Set up the wave function for the incoming and outgoing states. Solve the Schrödinger equation for the asymptotic regions. Solve the Schrödinger equation for the asymptotic regions. Use the Born approximation for weak scattering. Use the Born approximation for weak scattering. Calculate the scattering amplitude. Calculate the scattering amplitude. Find the differential cross-section. Find the differential cross-section. Apply the optical theorem for total cross-section. Apply the optical theorem for total cross-section. Compare theoretical and experimental cross-sections. Compare theoretical and experimental cross-sections.
Electrons act like waves sometimes. Electrons act like waves sometimes. Other times they're particles. Other times they're particles. Electrons are part of the electromagnetic field. Electrons are part of the electromagnetic field. Measuring an electron makes it act like a particle. Measuring an electron makes it act like a particle. Electrons are both waves and particles depending on observation. Electrons are both waves and particles depending on observation. This is wave-particle duality. This is wave-particle duality. Even experts get confused by it. Even experts get confused by it. Observing changes what we see. Observing changes what we see. Wave-particle duality is tricky but cool. Wave-particle duality is tricky but cool.
What's the most surprising result of a star collapsing into a black hole? What's the most surprising result of a star collapsing into a black hole? What would it feel like near a black hole's event horizon? What would it feel like near a black hole's event horizon? How does a black hole affect time? How does a black hole affect time? What would be your main fear encountering a black hole? What would be your main fear encountering a black hole? How do black holes challenge our universe's structure? How do black holes challenge our universe's structure? Can black holes affect nearby space without interacting directly? Can black holes affect nearby space without interacting directly? Could black holes be used for future travel or communication? Could black holes be used for future travel or communication? If black holes lead to other universes, how would that change reality? If black holes lead to other universes, how would that change reality? How could studying black holes change physics or philosophy? How could studying black holes change physics or philosophy? What question would you ask a physicist about black holes? What question would you ask a physicist about black holes?
Thermodynamics helps you understand how the world works. Thermodynamics helps you understand how the world works. With practice and patience, you can master thermodynamics. With practice and patience, you can master thermodynamics. The laws are simple once you grasp the basics. The laws are simple once you grasp the basics. It's normal to find thermodynamics confusing at first. It's normal to find thermodynamics confusing at first. Break down complex concepts to learn thermodynamics easily. Break down complex concepts to learn thermodynamics easily. Thermodynamics reveals beauty and elegance as you learn more. Thermodynamics reveals beauty and elegance as you learn more. Your understanding will grow as you explore new ideas. Your understanding will grow as you explore new ideas. Studying thermodynamics fosters respect for past scientists. Studying thermodynamics fosters respect for past scientists. You can learn thermodynamics, and we believe in your success. You can learn thermodynamics, and we believe in your success.
Write down the bare parameters of the theory. Write down the bare parameters of the theory. Identify the scale at which the theory is applied. Identify the scale at which the theory is applied. Calculate the flow of the coupling constants under renormalization. Calculate the flow of the coupling constants under renormalization. Determine the renormalization group equation. Determine the renormalization group equation. Solve the RG equation for the running parameters. Solve the RG equation for the running parameters. Identify fixed points of the RG flow. Identify fixed points of the RG flow. Classify the fixed points. Classify the fixed points. Determine the scaling behavior near the fixed points. Determine the scaling behavior near the fixed points. Perform a perturbative expansion if necessary. Perform a perturbative expansion if necessary. Use the results to predict physical phenomena at different scales. Use the results to predict physical phenomena at different scales.
Let's use a high-fidelity optical cavity. Let's use a high-fidelity optical cavity. We should implement a laser stabilization system. We should implement a laser stabilization system. This setup would benefit from an interferometric configuration. This setup would benefit from an interferometric configuration. A cryogenic cooling system is essential for optimal performance. A cryogenic cooling system is essential for optimal performance. The gravitational waves will be most effectively detected at this frequency. The gravitational waves will be most effectively detected at this frequency. We should consider using a vacuum chamber to minimize noise. We should consider using a vacuum chamber to minimize noise. This new design incorporates a dual recycling scheme. This new design incorporates a dual recycling scheme. A high-speed data acquisition system is required for accurate measurements. A high-speed data acquisition system is required for accurate measurements. Implementing a feedback loop will help stabilize the optical path. Implementing a feedback loop will help stabilize the optical path.
Superconducting magnets accelerate particles. Superconducting magnets accelerate particles. Quantum computers use superconducting qubits. Quantum computers use superconducting qubits. Magnetic levitation trains rely on superconductors. Magnetic levitation trains rely on superconductors. Superconducting cables transmit power efficiently. Superconducting cables transmit power efficiently. The Large Hadron Collider uses superconducting magnets. The Large Hadron Collider uses superconducting magnets. Superconducting circuits process information quickly. Superconducting circuits process information quickly. High-energy storage devices employ superconducting materials. High-energy storage devices employ superconducting materials. Medical imaging machines utilize superconducting coils. Medical imaging machines utilize superconducting coils. Power grids are enhanced by superconducting transmission lines. Power grids are enhanced by superconducting transmission lines. Neutron scattering instruments exploit superconducting magnets. Neutron scattering instruments exploit superconducting magnets.
The universe's true age is finally revealed. The universe's true age is finally revealed. Dark matter's nature is conclusively proven. Dark matter's nature is conclusively proven. Gravitational waves unlock secrets of the cosmos. Gravitational waves unlock secrets of the cosmos. First ever image of a black hole is captured. First ever image of a black hole is captured. The mystery of fast radio bursts is solved. The mystery of fast radio bursts is solved. Cosmic inflation's mechanism is fully understood. Cosmic inflation's mechanism is fully understood. The universe's expansion rate is precisely measured. The universe's expansion rate is precisely measured. A new fundamental force of nature is discovered. A new fundamental force of nature is discovered. The Higgs boson's role in the universe is clarified. The Higgs boson's role in the universe is clarified. Evidence for a multiverse is conclusively found. Evidence for a multiverse is conclusively found.
Gravity emerges from collective behavior. Gravity emerges from collective behavior. Quantum fluctuations dominate at cosmological scales. Quantum fluctuations dominate at cosmological scales. The holographic principle limits spacetime geometry. The holographic principle limits spacetime geometry. Dark matter may be due to incomplete information theory. Dark matter may be due to incomplete information theory. Quantum gravity needs new math beyond Riemannian manifolds. Quantum gravity needs new math beyond Riemannian manifolds. The cosmological constant problem remains unsolved. The cosmological constant problem remains unsolved. Spacetime may result from quantum entanglement. Spacetime may result from quantum entanglement. Non-perturbative effects are key to understanding quantum gravity. Non-perturbative effects are key to understanding quantum gravity.
It's great to meet you. I'm a postdoc from Harvard. It's great to meet you. I'm a postdoc from Harvard. I've been following your work on black hole simulations. I've been following your work on black hole simulations. This conference is really well organized, don't you think? This conference is really well organized, don't you think? I'm interested in learning more about your research on dark matter. I'm interested in learning more about your research on dark matter. Have you had a chance to explore the city during your stay here? Have you had a chance to explore the city during your stay here? Your talk this morning was really insightful. Thank you for sharing. Your talk this morning was really insightful. Thank you for sharing. What brought you to our department from Cambridge? What brought you to our department from Cambridge? I'm looking forward to hearing about your latest discoveries. I'm looking forward to hearing about your latest discoveries. We have a few collaborations on the horizon. Let's schedule a meeting. We have a few collaborations on the horizon. Let's schedule a meeting. Your work has some exciting implications for our own research project. Your work has some exciting implications for our own research project.
The universe is expanding at an incredible rate. The universe is expanding at an incredible rate. Galaxies are moving away from each other. Galaxies are moving away from each other. Stars and planets are speeding through space. Stars and planets are speeding through space. Light travels far and wide across the cosmos. Light travels far and wide across the cosmos. This invisible power accelerates the expansion. This invisible power accelerates the expansion. Scientists have detected its presence everywhere. Scientists have detected its presence everywhere. The effects of dark energy are undeniable and vast. The effects of dark energy are undeniable and vast. It's changing the fabric of space itself. It's changing the fabric of space itself. We still know very little about this cosmic enigma. We still know very little about this cosmic enigma.
String theory is often seen as a scientific dead end. String theory is often seen as a scientific dead end. The lack of experimental evidence for strings is concerning. The lack of experimental evidence for strings is concerning. Many physicists doubt the multiverse concept. Many physicists doubt the multiverse concept. There's no consensus on string theory's predictions. There's no consensus on string theory's predictions. The complexity of string theory is overwhelming. The complexity of string theory is overwhelming. The variety of string theory models causes confusion. The variety of string theory models causes confusion. String theory's explanation of gravity has failed. String theory's explanation of gravity has failed.
We'll explore fusion energy as a clean power source. We'll explore fusion energy as a clean power source. The research will study superheavy elements via particle collisions. The research will study superheavy elements via particle collisions. We'll investigate nuclear clusters in extreme conditions. We'll investigate nuclear clusters in extreme conditions. We propose analyzing neutron scattering for nuclear insights. We propose analyzing neutron scattering for nuclear insights. We'll examine parity-violating interactions in nuclear systems. We'll examine parity-violating interactions in nuclear systems. Our goal is to apply nuclear techniques in medical imaging and treatment. Our goal is to apply nuclear techniques in medical imaging and treatment. We aim to study dark matter using high-energy particle beams. We aim to study dark matter using high-energy particle beams. We aim to develop new methods for nuclear data analysis. We aim to develop new methods for nuclear data analysis.
Reality is fundamentally probabilistic. Reality is fundamentally probabilistic. The observer effect is a real phenomenon. The observer effect is a real phenomenon. Quantum entanglement is a non-local process. Quantum entanglement is a non-local process. Wave function collapse is an objective occurrence. Wave function collapse is an objective occurrence. Superposition exists in physical systems. Superposition exists in physical systems. The concept of decoherence is well defined. The concept of decoherence is well defined. Reality is relative to the observer's frame of reference. Reality is relative to the observer's frame of reference. The many worlds interpretation is a viable explanation. The many worlds interpretation is a viable explanation. Quantum mechanics governs all physical phenomena. Quantum mechanics governs all physical phenomena. Consciousness plays a key role in reality creation. Consciousness plays a key role in reality creation.
The universe may be fundamentally indeterminate. The universe may be fundamentally indeterminate. Physical laws govern all phenomena equally. Physical laws govern all phenomena equally. Reality is an emergent property of quantum fluctuations. Reality is an emergent property of quantum fluctuations. Consciousness is the fundamental aspect of reality. Consciousness is the fundamental aspect of reality. Observer effects imply a participatory role for consciousness. Observer effects imply a participatory role for consciousness. Quantum mechanics reveals the inherent ambiguity of reality. Quantum mechanics reveals the inherent ambiguity of reality. Causality is an emergent property of deterministic physical systems. Causality is an emergent property of deterministic physical systems. The universe has a preferred state which we may be approaching. The universe has a preferred state which we may be approaching. Reality is in principle computable and predictable. Reality is in principle computable and predictable.
Identify the metric of the spacetime. Identify the metric of the spacetime. Compute the Christoffel symbols from the metric. Compute the Christoffel symbols from the metric. Write the geodesic equation for the motion. Write the geodesic equation for the motion. Solve the equation for the particle's path. Solve the equation for the particle's path. Use symmetries to simplify the problem. Use symmetries to simplify the problem. Consider known solutions. Consider known solutions. Calculate the curvature of spacetime. Calculate the curvature of spacetime. Apply initial conditions for position and velocity. Apply initial conditions for position and velocity. Interpret the results in terms of geodesic motion. Interpret the results in terms of geodesic motion. Analyze the deviation of nearby geodesics. Analyze the deviation of nearby geodesics.
Mathematics should not be the sole foundation of physical theories. Mathematics should not be the sole foundation of physical theories. Theoretical physics has become too reliant on abstract mathematics. Theoretical physics has become too reliant on abstract mathematics. Mathematical models are no substitute for actual observations. Mathematical models are no substitute for actual observations. The beauty of math should not obscure the truth of nature. The beauty of math should not obscure the truth of nature. Theory without experiment is mere speculation. Theory without experiment is mere speculation. Formalism is a tool, not a replacement for physical intuition. Formalism is a tool, not a replacement for physical intuition. Mathematical rigor should serve the cause of physics, not control it. Mathematical rigor should serve the cause of physics, not control it. Theoretical physicists must return to their empirical roots. Theoretical physicists must return to their empirical roots.
Nuclear physics aids in understanding radiation interactions. Nuclear physics aids in understanding radiation interactions. Nuclear techniques analyze hydrogen fuel cells. Nuclear techniques analyze hydrogen fuel cells. Nuclear physics aids in designing better thermal storage systems. Nuclear physics aids in designing better thermal storage systems. These advances enable greater energy storage for renewable grids. These advances enable greater energy storage for renewable grids. This research also enhances our understanding of geothermal energy. This research also enhances our understanding of geothermal energy. Nuclear techniques improve tidal energy technologies. Nuclear techniques improve tidal energy technologies. These innovations help harness renewable energy more effectively. These innovations help harness renewable energy more effectively.
Transistors replaced vacuum tubes. Transistors replaced vacuum tubes. Quantum mechanics enabled transistor miniaturization. Quantum mechanics enabled transistor miniaturization. Microchips integrated multiple transistors. Microchips integrated multiple transistors. Microchips revolutionized computer design. Microchips revolutionized computer design. Integrated circuits created smaller computers. Integrated circuits created smaller computers. Smaller computers allowed more efficient data processing. Smaller computers allowed more efficient data processing. Transistorized amplifiers improved audio quality. Transistorized amplifiers improved audio quality. Solid-state devices replaced vacuum tubes. Solid-state devices replaced vacuum tubes.
Quantum physics led to faster, smaller components. Quantum physics led to faster, smaller components.
Quantum tunneling enabled smaller transistors. Quantum tunneling enabled smaller transistors.
You will not be sucked into a black hole if you get too close. You will not be sucked into a black hole if you get too close. Black holes have no solid surface. Black holes have no solid surface. The event horizon is the escape boundary, not a density increase. The event horizon is the escape boundary, not a density increase. You can't see a black hole's shadow. You can't see a black hole's shadow. Spin, not size, determines a black hole's mass. Spin, not size, determines a black hole's mass. Small black holes are hot, but not as hot as stars. Small black holes are hot, but not as hot as stars. Once inside the event horizon, escape is impossible. Once inside the event horizon, escape is impossible. Black holes aren't portals, just regions of strong gravity. Black holes aren't portals, just regions of strong gravity.
The data shows positive mass density at the galaxy's center. The data shows positive mass density at the galaxy's center. Deflection angles match theoretical predictions. Deflection angles match theoretical predictions. No significant substructure found in the lensing system. No significant substructure found in the lensing system. Mass distribution fits a single spherical halo. Mass distribution fits a single spherical halo. A strong shear signal is detected along the galaxy's major axis. A strong shear signal is detected along the galaxy's major axis. The mass map reveals a complex multi-component system. The mass map reveals a complex multi-component system. The gravitational potential is dominated by dark matter. The gravitational potential is dominated by dark matter. Observed and simulated distortion profiles align well. Observed and simulated distortion profiles align well.
Biophysics merges physics and biology to understand living systems. Biophysics merges physics and biology to understand living systems. It studies how physical laws govern biological processes. It studies how physical laws govern biological processes. Physics helps analyze cell dynamics and components. Physics helps analyze cell dynamics and components. Physics explains protein folding and structure. Physics explains protein folding and structure. Biophysicists use mathematical modeling for biological systems. Biophysicists use mathematical modeling for biological systems. Physical principles govern biomolecules like DNA and proteins. Physical principles govern biomolecules like DNA and proteins. Biophysics aids in understanding diseases at the molecular level. Biophysics aids in understanding diseases at the molecular level. Thermodynamics governs energy conversion in biological systems. Thermodynamics governs energy conversion in biological systems. Biophysicists use imaging to visualize cellular and molecular processes. Biophysicists use imaging to visualize cellular and molecular processes.
Solve the Schrödinger equation. Solve the Schrödinger equation. Define the Hamiltonian operator. Define the Hamiltonian operator. Use a potential energy function. Use a potential energy function. Find normalized wave functions. Find normalized wave functions. Use separation of variables. Use separation of variables. Solve for the time-independent wave function. Solve for the time-independent wave function. Apply boundary conditions for valid solutions. Apply boundary conditions for valid solutions.
Determine I in functions. Determine I in functions.
Use numerical methods to solve for values. Use numerical methods to solve for values. Express final result as a function of energy. Express final result as a function of energy.
Identify relevant physical laws. Identify relevant physical laws.
Choose the appropriate mathematical framework. Choose the appropriate mathematical framework.
Define the integration variable. Define the integration variable. Specify the integration bounds. Specify the integration bounds. Select an integration method. Select an integration method. Compute the integral. Compute the integral. Check for errors in calculations. Check for errors in calculations. Validate results with known constants. Validate results with known constants. Interpret results in the context of electromagnetism. Interpret results in the context of electromagnetism. Accurately integrate functions using these steps. Accurately integrate functions using these steps.
Time evolution is described by an initial wave function. Time evolution is described by an initial wave function. The Hamiltonian operator represents the system's total energy. The Hamiltonian operator represents the system's total energy. The expectation value defines the average energy. The expectation value defines the average energy. Wave function evolution is linked to energy I in values and ion functions. Wave function evolution is linked to energy I in values and ion functions. A differential equation for the wave function is derived. A differential equation for the wave function is derived. In one dimension, this is the Schrödinger equation. In one dimension, this is the Schrödinger equation. The time-dependent Schrödinger equation describes dynamic behavior. The time-dependent Schrödinger equation describes dynamic behavior.
The motion of each body is independent of the other. The motion of each body is independent of the other. There are no external forces acting on either body. There are no external forces acting on either body. The only force between the two bodies is gravity. The only force between the two bodies is gravity. Each body's mass is constant and unchanging. Each body's mass is constant and unchanging. The bodies are point masses with no size or shape. The bodies are point masses with no size or shape. There are no other forces acting on the system besides gravity. There are no other forces acting on the system besides gravity. Newton's laws of motion apply to both bodies equally. Newton's laws of motion apply to both bodies equally. The universe is an inertial reference frame for this problem. The universe is an inertial reference frame for this problem. Air resistance and other external effects are negligible. Air resistance and other external effects are negligible.
Identify key principles. Identify key principles. List given quantities. List given quantities. Use the Schrödinger equation. Use the Schrödinger equation. Apply Lorentz transformations. Apply Lorentz transformations. Consider wave-particle duality. Consider wave-particle duality. Use the uncertainty principle. Use the uncertainty principle. Check conservation laws. Check conservation laws. Simplify with symmetries. Simplify with symmetries. Use natural units. Use natural units. Verify with experiments. Verify with experiments.
The energy of the hydrogen atom is governed by its Hamiltonian. The energy of the hydrogen atom is governed by its Hamiltonian. We solve the time-independent Schrödinger equation for the atom. We solve the time-independent Schrödinger equation for the atom. This leads to a differential equation that describes the system. This leads to a differential equation that describes the system. The solution describes the wave function of the electron. The solution describes the wave function of the electron. Substituting it gives us the allowed energy levels. Substituting it gives us the allowed energy levels. The energy levels depend on the quantum state of the electron. The energy levels depend on the quantum state of the electron. The ground state corresponds to the lowest energy level. The ground state corresponds to the lowest energy level. Excited states have higher energy levels with more kinetic energy. Excited states have higher energy levels with more kinetic energy. Each energy level has its own set of quantum numbers. Each energy level has its own set of quantum numbers.
The string is fixed at both ends. The string is fixed at both ends. The string vibrates with no reflection on the left end. The string vibrates with no reflection on the left end. There are no incoming waves from the right end. There are no incoming waves from the right end. The string is open on one end and closed on the other. The string is open on one end and closed on the other. Waves can only enter from the left side. Waves can only enter from the left side. The string has a fixed length with free ends. The string has a fixed length with free ends. No outgoing waves are allowed to the right. No outgoing waves are allowed to the right. The boundary conditions require zero amplitude at both ends. The boundary conditions require zero amplitude at both ends. The string is tied down on one end and loose on the other. The string is tied down on one end and loose on the other. There is no wave transmission through either end. There is no wave transmission through either end.
We start with an unnormalized wave function. We start with an unnormalized wave function. The goal is to normalize it to unity. The goal is to normalize it to unity. Normalization requires integrating the wave function over all space. Normalization requires integrating the wave function over all space. We square the wave function at each point. We square the wave function at each point. We then integrate the squared value over all space. We then integrate the squared value over all space. To normalize, we divide the wave function by its norm. To normalize, we divide the wave function by its norm. This ensures the wave function integrates to unity. This ensures the wave function integrates to unity. Normalization is essential for a meaningful wave function. Normalization is essential for a meaningful wave function. Normalizing ensures the wave function is a valid quantum state. Normalizing ensures the wave function is a valid quantum state.
The Christoffel symbol is indeed 0 at this point. The Christoffel symbol is indeed 0 at this point. We can proceed with the assumption of flat spacetime. We can proceed with the assumption of flat spacetime. This simplification is justified by the specific coordinates used. This simplification is justified by the specific coordinates used. No, we must use the correct metric signature here. No, we must use the correct metric signature here. The Riemann tensor reduces to a simple expression under these conditions. The Riemann tensor reduces to a simple expression under these conditions.
Yes, the Beachy scalar is calculated correctly in this case. Yes, the Beachy scalar is calculated correctly in this case.
We can drop this term as it's negligible due to symmetry arguments. We can drop this term as it's negligible due to symmetry arguments. This particular component of the Einstein tensor is 0 anyway. This particular component of the Einstein tensor is 0 anyway. The calculations are consistent with the given initial conditions. The calculations are consistent with the given initial conditions.
The Jacobian determinant scales the area element. The Jacobian determinant scales the area element.
Jacobian determinants preserve volume in transformations. Jacobian determinants preserve volume in transformations.
We compute the Jacobian for each point. We compute the Jacobian for each point. The Jacobian matrix and its determinant are crucial. The Jacobian matrix and its determinant are crucial.
The scaling factor is the absolute value of the Jacobian. The scaling factor is the absolute value of the Jacobian. A Jacobian value of 1 preserves area. A Jacobian value of 1 preserves area. Negative Jacobians result from improper orientation. Negative Jacobians result from improper orientation.
The determinant shows how area changes across dimensions. The determinant shows how area changes across dimensions. Use the absolute value of the Jacobian for integration. Use the absolute value of the Jacobian for integration. Jacobian determinants relate to change of basis in vector spaces. Jacobian determinants relate to change of basis in vector spaces.
Start by writing the partial differential equation. Start by writing the partial differential equation. Assume a solution that separates the variables. Assume a solution that separates the variables. Substitute the solution into the equation. Substitute the solution into the equation. Simplify and group similar terms. Simplify and group similar terms. This results in 2 separate ordinary differential equations. This results in 2 separate ordinary differential equations. Solve the first equation with appropriate conditions. Solve the first equation with appropriate conditions. Substitute the solution back into the assumed form. Substitute the solution back into the assumed form. Solve the second equation with initial conditions. Solve the second equation with initial conditions. Combine both solutions for the final result. Combine both solutions for the final result. Check the solution by substituting it into the original equation. Check the solution by substituting it into the original equation.
Initial conditions specify the starting point. Initial conditions specify the starting point. Maxwell's equations require initial values to solve. Maxwell's equations require initial values to solve. Initial conditions uniquely determine the solution. Initial conditions uniquely determine the solution. Specifying initial conditions is crucial for a unique answer. Specifying initial conditions is crucial for a unique answer. The choice of initial conditions affects the outcome. The choice of initial conditions affects the outcome. They define the system's state at the beginning. They define the system's state at the beginning. Maxwell's equations depend on well-defined initial values. Maxwell's equations depend on well-defined initial values. Initial conditions enable us to solve for the rest. Initial conditions enable us to solve for the rest. They give us a clear picture from the start. They give us a clear picture from the start.
The matrix A is not square. The matrix A is not square. The characteristic equation has no real roots. The characteristic equation has no real roots. The determinant of the coefficient matrix is 0. The determinant of the coefficient matrix is 0.
The I in vector calculations involve an unknown constant. The I in vector calculations involve an unknown constant. The diagonalization process assumes a unique set of eigenvectors. The diagonalization process assumes a unique set of eigenvectors. The eigenvalues are calculated using incorrect linear combinations. The eigenvalues are calculated using incorrect linear combinations. The eigenvector calculations do not account for scaling factors. The eigenvector calculations do not account for scaling factors.
The determinant of the matrix is incorrectly calculated as 0. The determinant of the matrix is incorrectly calculated as 0. The inverse of the coefficient matrix does not exist. The inverse of the coefficient matrix does not exist.
The boundary layer plays a crucial role in aerodynamics. The boundary layer plays a crucial role in aerodynamics. It's where drag and friction occur in fluids. It's where drag and friction occur in fluids. Boundary layers affect the flow of gases around objects. Boundary layers affect the flow of gases around objects. They determine the efficiency of airfoils and wings. They determine the efficiency of airfoils and wings. The thickness of boundary layers is crucial for aircraft performance. The thickness of boundary layers is crucial for aircraft performance. Boundary layer separation leads to drag and reduced lift. Boundary layer separation leads to drag and reduced lift. It's essential for understanding wind resistance and turbulence. It's essential for understanding wind resistance and turbulence. The study of boundary layers helps design more efficient engines. The study of boundary layers helps design more efficient engines. They are critical for predicting airflow around buildings and bridges. They are critical for predicting airflow around buildings and bridges. Boundary layer thickness affects the accuracy of CFD models. Boundary layer thickness affects the accuracy of CFD models.
Define the mass distribution of the object. Define the mass distribution of the object. Choose an axis of rotation. Choose an axis of rotation. Calculate the moment of inertia for each element. Calculate the moment of inertia for each element. Integrate to find the total moment of inertia. Integrate to find the total moment of inertia. Simplify the calculation using symmetry if possible. Simplify the calculation using symmetry if possible. Use formulas for each shape in the object. Use formulas for each shape in the object. Account for any holes or cavities. Account for any holes or cavities. Verify the moment of inertia calculation. Verify the moment of inertia calculation. Check the units of the moment of inertia. Check the units of the moment of inertia. Record the final result. Record the final result.
The Laplace transform solves time-dependent problems effectively. The Laplace transform solves time-dependent problems effectively. It converts differential equations into algebraic ones. It converts differential equations into algebraic ones. This simplifies and makes the solution process more intuitive. This simplifies and makes the solution process more intuitive. It models real-world systems, like RLC circuits. It models real-world systems, like RLC circuits. It's used in control theory and signal processing. It's used in control theory and signal processing. It simplifies the analysis of complex systems. It simplifies the analysis of complex systems. These representations offer insights into system behavior. These representations offer insights into system behavior. The inverse Laplace transform retrieves time-domain solutions. The inverse Laplace transform retrieves time-domain solutions. This involves finding the original function from its transform. This involves finding the original function from its transform.
This approach simplifies calculations. This approach simplifies calculations. It reduces computational complexity. It reduces computational complexity. The results match experimental data well. The results match experimental data well. This method converges quickly enough. This method converges quickly enough. We can obtain accurate enough results with it. We can obtain accurate enough results with it. It provides a good initial estimate. It provides a good initial estimate. Simplifying assumptions are reasonable here. Simplifying assumptions are reasonable here. Computational resources are limited. Computational resources are limited. A simple model is sufficient for this case. A simple model is sufficient for this case. This approximation method is widely used and trusted. This approximation method is widely used and trusted.
Divide both sides by the same units. Divide both sides by the same units. Simplify the expression on the right-hand side. Simplify the expression on the right-hand side. Cancel out the common factors in the numerator and denominator. Cancel out the common factors in the numerator and denominator. Reduce the fraction to its simplest form. Reduce the fraction to its simplest form. Eliminate any unit that cancels out with itself. Eliminate any unit that cancels out with itself. Simplify the coefficients by multiplying them together. Simplify the coefficients by multiplying them together. Combine like terms on both sides of the equation. Combine like terms on both sides of the equation. Remove any parentheses and simplify inside them. Remove any parentheses and simplify inside them. Simplify the fraction using its prime factors. Simplify the fraction using its prime factors. Write the simplified equation in standard form. Write the simplified equation in standard form.
Fourier series solves periodic problems effectively. Fourier series solves periodic problems effectively. It models and analyzes complex periodic phenomena. It models and analyzes complex periodic phenomena. It breaks down problems into sums of sinusoids. It breaks down problems into sums of sinusoids. The coefficients reveal important system information. The coefficients reveal important system information. Fourier analysis is key to understanding periodic signals and systems. Fourier analysis is key to understanding periodic signals and systems. It decomposes complex signals into their fundamental components. It decomposes complex signals into their fundamental components. It provides insights into the physical mechanisms of systems. It provides insights into the physical mechanisms of systems. It's widely used in engineering and physics. It's widely used in engineering and physics. Fourier analysis is crucial for solving periodic behavior problems. Fourier analysis is crucial for solving periodic behavior problems.
The displacement field represents the actual motion of the system. The displacement field represents the actual motion of the system. Each point on the surface corresponds to a specific location in space. Each point on the surface corresponds to a specific location in space. The amplitude of each point gives its intensity or magnitude. The amplitude of each point gives its intensity or magnitude. Time-dependent solutions describe transient behavior. Time-dependent solutions describe transient behavior. Displacement is a scalar quantity that varies both in space and time. Displacement is a scalar quantity that varies both in space and time. Boundary conditions dictate the behavior of waves at system boundaries. Boundary conditions dictate the behavior of waves at system boundaries.
Using consistent units is crucial for accurate calculations. Using consistent units is crucial for accurate calculations. Dimensional analysis catches errors before they cause problems. Dimensional analysis catches errors before they cause problems. Consistent unit systems prevent silly mistakes. Consistent unit systems prevent silly mistakes. Precision in units ensures precision in results. Precision in units ensures precision in results. Don't mix units or your math will suffer the consequences. Don't mix units or your math will suffer the consequences. Correct units are key to solving complex equations. Correct units are key to solving complex equations. Consistent unit usage is a hallmark of good scientific practice. Consistent unit usage is a hallmark of good scientific practice. Dimensional consistency is essential for reliable mathematical results. Dimensional consistency is essential for reliable mathematical results.
Start with the original nonlinear equation. Start with the original nonlinear equation. Assume small perturbations around a known solution. Assume small perturbations around a known solution. Linearize the equation by taking partial derivatives. Linearize the equation by taking partial derivatives. Calculate the Jacobian matrix of the function. Calculate the Jacobian matrix of the function. Apply the Taylor series expansion to the nonlinear equation. Apply the Taylor series expansion to the nonlinear equation. Retain only the first-order terms in the expansion. Retain only the first-order terms in the expansion. The resulting linearized equation is a system of linear equations. The resulting linearized equation is a system of linear equations. Solve the linearized equation for the perturbation variables. Solve the linearized equation for the perturbation variables. Verify that the linearization accurately captures the behavior. Verify that the linearization accurately captures the behavior.
Conservation laws simplify complex problems. Conservation laws simplify complex problems. They identify conserved quantities and properties. They identify conserved quantities and properties. Understanding conservation laws is key for solving physics problems. Understanding conservation laws is key for solving physics problems. These laws ensure physical systems remain unchanged over time. These laws ensure physical systems remain unchanged over time. Conservation laws are vital for analyzing dynamic systems. Conservation laws are vital for analyzing dynamic systems. They are a powerful tool in mechanics and electromagnetism. They are a powerful tool in mechanics and electromagnetism.
We will start with an initial guess. We will start with an initial guess. The algorithm will iteratively refine this guess. The algorithm will iteratively refine this guess. Each iteration will produce a new estimate of the solution. Each iteration will produce a new estimate of the solution. These estimates will converge to the actual solution over time. These estimates will converge to the actual solution over time. The process is repeated until the desired precision is achieved. The process is repeated until the desired precision is achieved. We will use a numerical method such as Newton's method or bisection. We will use a numerical method such as Newton's method or bisection. The iterative process allows us to handle non-linear equations with ease. The iterative process allows us to handle non-linear equations with ease. Each iteration will update the estimate based on the function's behavior. Each iteration will update the estimate based on the function's behavior. This procedure ensures a high degree of accuracy in our solution. This procedure ensures a high degree of accuracy in our solution.
Write the wave function. Write the wave function. Apply boundary conditions. Apply boundary conditions. Normalize the wave function. Normalize the wave function. Calculate expectation values. Calculate expectation values. Use operators for observables. Use operators for observables. Apply perturbation theory. Apply perturbation theory.
Solve for I in values. Solve for I in values.
Check orthogonality. Check orthogonality. Use the Born rule. Use the Born rule. Verify with known solutions. Verify with known solutions.
Symmetry reduces the complexity of quantum systems. Symmetry reduces the complexity of quantum systems. It focuses on a smaller subset of states. It focuses on a smaller subset of states. Symmetry simplifies the mathematical description of quantum mechanics. Symmetry simplifies the mathematical description of quantum mechanics. It highlights the essential features of quantum systems. It highlights the essential features of quantum systems. Symmetry is a powerful tool for analyzing complex quantum phenomena. Symmetry is a powerful tool for analyzing complex quantum phenomena. It enables more accurate predictions of quantum behavior. It enables more accurate predictions of quantum behavior. Symmetry is crucial for understanding quantum field theories. Symmetry is crucial for understanding quantum field theories. It helps identify symmetries vital for precise calculations. It helps identify symmetries vital for precise calculations. It allows the use of results from simpler symmetric systems. It allows the use of results from simpler symmetric systems.
The photoelectric effect revealed light's particle-like behavior. The photoelectric effect revealed light's particle-like behavior. It showed light behaves as both waves and particles. It showed light behaves as both waves and particles. This challenged classical physics and led to quantum mechanics. This challenged classical physics and led to quantum mechanics. Einstein's explanation of the effect was a major breakthrough. Einstein's explanation of the effect was a major breakthrough. Photon energy determines the kinetic energy of electrons. Photon energy determines the kinetic energy of electrons. The effect demonstrated energy quantization in physics. The effect demonstrated energy quantization in physics. It shifted the view from wave theory to particle theory. It shifted the view from wave theory to particle theory. The photoelectric effect led to many quantum physics discoveries. The photoelectric effect led to many quantum physics discoveries. Einstein won the Nobel Prize for his work on the effect. Einstein won the Nobel Prize for his work on the effect.
Mass and energy warp the fabric of space. Mass and energy warp the fabric of space. The more massive an object, the stronger its gravitational pull. The more massive an object, the stronger its gravitational pull. Relativity shows gravity affects time just like space. Relativity shows gravity affects time just like space. Spacetime curvature causes objects to follow curved paths. Spacetime curvature causes objects to follow curved paths. Gravity is an effect of spacetime geometry, not a one-way force. Gravity is an effect of spacetime geometry, not a one-way force. Even small masses cause significant distortions in spacetime. Even small masses cause significant distortions in spacetime. The laws of physics are the same everywhere regardless of gravity. The laws of physics are the same everywhere regardless of gravity. General relativity shows gravity is an emergent property. General relativity shows gravity is an emergent property.
Black holes are key to advancing general relativity. Black holes are key to advancing general relativity. They help us understand matter and energy in extreme conditions. They help us understand matter and energy in extreme conditions. Black holes drive innovation in astrophysics and cosmology. Black holes drive innovation in astrophysics and cosmology. Research informs our understanding of supernova and gamma-ray bursts. Research informs our understanding of supernova and gamma-ray bursts. They refine our understanding of cosmic evolution and galaxy formation. They refine our understanding of cosmic evolution and galaxy formation. Black holes offer insights into dark matter and dark energy. Black holes offer insights into dark matter and dark energy. Ongoing research reveals secrets about the laws of the universe. Ongoing research reveals secrets about the laws of the universe.
Nuclear power plants provide low carbon energy. Nuclear power plants provide low carbon energy. Fission reactions generate abundant electricity. Fission reactions generate abundant electricity. Uranium fuels are a reliable energy source. Uranium fuels are a reliable energy source. Nuclear energy reduces greenhouse gas emissions. Nuclear energy reduces greenhouse gas emissions. Reactor design improves efficiency and safety. Reactor design improves efficiency and safety. Advanced nuclear technologies boost economic growth. Advanced nuclear technologies boost economic growth. Radioisotope batteries power remote facilities. Radioisotope batteries power remote facilities. Nuclear fusion holds promise for clean energy. Nuclear fusion holds promise for clean energy. Nuclear power stimulates technological innovation. Nuclear power stimulates technological innovation.
The wave function describes a quantum state. The wave function describes a quantum state. It contains all possible values and probabilities of the system. It contains all possible values and probabilities of the system. The square of the wave function's magnitude gives the probability density. The square of the wave function's magnitude gives the probability density. Schrödinger's equation finds the wave function's time evolution. Schrödinger's equation finds the wave function's time evolution. This equation links the wave function to its energy through the Hamiltonian. This equation links the wave function to its energy through the Hamiltonian. The Hamiltonian represents the total energy of the system. The Hamiltonian represents the total energy of the system. In quantum mechanics, energy and time are interchangeable. In quantum mechanics, energy and time are interchangeable. The wave function is an energy I function. The wave function is an energy I function. Each I-value corresponds to a unique energy level. Each I-value corresponds to a unique energy level.
More massive objects cause greater spacetime curvature. More massive objects cause greater spacetime curvature. Mass warps spacetime, creating a gravitational field. Mass warps spacetime, creating a gravitational field. Think of a heavy ball on a trampoline bending spacetime. Think of a heavy ball on a trampoline bending spacetime. Spacetime curvature affects the paths of nearby objects. Spacetime curvature affects the paths of nearby objects. Massive objects curve time itself according to Einstein. Massive objects curve time itself according to Einstein. Stronger gravitational fields have a greater effect on spacetime. Stronger gravitational fields have a greater effect on spacetime. Two balls on a trampoline illustrate geodesic lines in spacetime. Two balls on a trampoline illustrate geodesic lines in spacetime. Any massive object causes spacetime curvature around it. Any massive object causes spacetime curvature around it. Spacetime curvature is what we experience as gravity. Spacetime curvature is what we experience as gravity. Gravitational waves are ripples in spacetime from massive events. Gravitational waves are ripples in spacetime from massive events.
Entangled particles don't communicate faster than light. Entangled particles don't communicate faster than light. Quantum entanglement can't teleport macroscopic objects. Quantum entanglement can't teleport macroscopic objects. The EPR paradox was a thought experiment. The EPR paradox was a thought experiment. Quantum mechanics is not magic or supernatural. Quantum mechanics is not magic or supernatural. Entangled particles retain individual properties until measured. Entangled particles retain individual properties until measured. Quantum non-locality doesn't imply psychic connections. Quantum non-locality doesn't imply psychic connections. Quantum entanglement is predictable and well understood. Quantum entanglement is predictable and well understood. Entangled particles don't influence each other's states remotely. Entangled particles don't influence each other's states remotely.
The universe is full of mysteries waiting to be uncovered. The universe is full of mysteries waiting to be uncovered. Stars are born from swirling clouds of gas and dust. Stars are born from swirling clouds of gas and dust. Black holes warp the fabric of space-time around them. Black holes warp the fabric of space-time around them. Galaxies collide in a cosmic dance through billions of years. Galaxies collide in a cosmic dance through billions of years. The Big Bang was the birth of our universe, setting everything in motion. The Big Bang was the birth of our universe, setting everything in motion. Planets orbit around their stars in perfect harmony. Planets orbit around their stars in perfect harmony.
The Higgs boson is a fundamental particle in our universe. The Higgs boson is a fundamental particle in our universe.
It plays a crucial role in giving other particles mass. It plays a crucial role in giving other particles mass. Without it, particles would zip by each other unimpeded. Without it, particles would zip by each other unimpeded.
The Higgs boson discovery confirmed the Standard Model of physics. The Higgs boson discovery confirmed the Standard Model of physics.
Its existence explains why some forces are weak and others strong. Its existence explains why some forces are weak and others strong. It revealed a new aspect of the universe's quantum nature. It revealed a new aspect of the universe's quantum nature. The Higgs boson has deepened our understanding of matter itself. The Higgs boson has deepened our understanding of matter itself. Its discovery is a triumph for human curiosity and ingenuity. Its discovery is a triumph for human curiosity and ingenuity.
The Higgs boson continues to inspire scientific exploration and research. The Higgs boson continues to inspire scientific exploration and research.
Max Planck called a perfect light absorber a black body. Max Planck called a perfect light absorber a black body.
The ultraviolet catastrophe challenged classical theories. The ultraviolet catastrophe challenged classical theories. Planck introduced quantized energy in his radiation law. Planck introduced quantized energy in his radiation law. This idea revolutionized physics and founded quantum theory. This idea revolutionized physics and founded quantum theory. The photoelectric effect showed light behaves as particles or photons. The photoelectric effect showed light behaves as particles or photons. Bohr's atomic model used energy quantization to explain spectral lines. Bohr's atomic model used energy quantization to explain spectral lines. Heisenberg's uncertainty principle solidified quantum mechanics. Heisenberg's uncertainty principle solidified quantum mechanics. Quantum theory has been rigorously tested and refined. Quantum theory has been rigorously tested and refined.
Symmetry is a fundamental aspect of our universe. Symmetry is a fundamental aspect of our universe. Matter and energy behave similarly under certain conditions. Matter and energy behave similarly under certain conditions. The laws of physics remain unchanged with every reflection. The laws of physics remain unchanged with every reflection. Rotational symmetry allows for efficient calculations in quantum mechanics. Rotational symmetry allows for efficient calculations in quantum mechanics. Reflection symmetry reveals the hidden patterns in crystal structures. Reflection symmetry reveals the hidden patterns in crystal structures. Parity conservation is a cornerstone of particle physics theory. Parity conservation is a cornerstone of particle physics theory. The symmetries of nature are reflected in the beauty of geometric patterns. The symmetries of nature are reflected in the beauty of geometric patterns.
Wi-Fi provides wireless internet access everywhere. Wi-Fi provides wireless internet access everywhere. Microwaves cook and reheat food quickly. Microwaves cook and reheat food quickly. Radio broadcasts deliver music, news, and entertainment worldwide. Radio broadcasts deliver music, news, and entertainment worldwide. GPS helps navigate cities and routes accurately. GPS helps navigate cities and routes accurately. X-rays assist in medical diagnosis and treatment. X-rays assist in medical diagnosis and treatment. Televisions use electromagnetic waves to display content. Televisions use electromagnetic waves to display content. Radar helps pilots navigate through fog or storms. Radar helps pilots navigate through fog or storms. Mobile phones use cellular networks to stay connected. Mobile phones use cellular networks to stay connected. Computers transmit and receive data via electromagnetic waves. Computers transmit and receive data via electromagnetic waves.
The universe is still expanding. The universe is still expanding. This radiation has been traveling through space ever since. This radiation has been traveling through space ever since. It's the glow of all the matter and energy in the universe at that time. It's the glow of all the matter and energy in the universe at that time. These observations have helped us map the universe in unprecedented detail. These observations have helped us map the universe in unprecedented detail.
Radioactivity was discovered by Henry Becquerel. Radioactivity was discovered by Henry Becquerel. It has numerous applications in medicine, including cancer treatment. It has numerous applications in medicine, including cancer treatment. Radioisotopes are used to diagnose and treat various diseases. Radioisotopes are used to diagnose and treat various diseases. Ernest Lawrence invented the cyclotron particle accelerator. Ernest Lawrence invented the cyclotron particle accelerator.
Isotopes are used to date archaeological and historical artifacts. Isotopes are used to date archaeological and historical artifacts.
Heat energy is vital for life on Earth. Heat energy is vital for life on Earth. The universe's entropy increases over time with heat transfer. The universe's entropy increases over time with heat transfer. Heat engines convert thermal energy into mechanical work. Heat engines convert thermal energy into mechanical work. Thermodynamics helps us understand gas behavior in space. Thermodynamics helps us understand gas behavior in space. Heat is kinetic energy that can be transferred or transformed. Heat is kinetic energy that can be transferred or transformed. The Earth's climate system uses thermodynamics to regulate temperature. The Earth's climate system uses thermodynamics to regulate temperature. Stars shine due to nuclear reactions that release heat and light. Stars shine due to nuclear reactions that release heat and light.
Start with the simplest terms. Start with the simplest terms. Combine like terms first. Combine like terms first. Simplify within parentheses first. Simplify within parentheses first. Cancel out identical factors. Cancel out identical factors. Factor out common denominators. Factor out common denominators. Look for opportunities to cancel. Look for opportunities to cancel. Reduce fractions and decimals together. Reduce fractions and decimals together. Eliminate negative signs in front of fractions. Eliminate negative signs in front of fractions. Simplify expressions inside brackets first. Simplify expressions inside brackets first. Use exponents to simplify repeated numbers. Use exponents to simplify repeated numbers.
Dark matter surrounds us. Dark matter surrounds us. It accounts for most of the universe's mass energy. It accounts for most of the universe's mass energy. Galaxies move rapidly due to its gravitational pull. Galaxies move rapidly due to its gravitational pull. Despite its name, dark matter isn't visually dark. Despite its name, dark matter isn't visually dark. It interacts with normal matter only via gravity and collisions. It interacts with normal matter only via gravity and collisions. Scientists still don't know its exact composition. Scientists still don't know its exact composition.
The universe is just one of many infinite possibilities. The universe is just one of many infinite possibilities. In the grand scheme, every decision creates a new universe. In the grand scheme, every decision creates a new universe. The multiverse is full of alternate histories and parallel universes. The multiverse is full of alternate histories and parallel universes. Our reality is just one tiny thread in the vast tapestry of the multiverse. Our reality is just one tiny thread in the vast tapestry of the multiverse. The multiverse is an endless ocean of possibilities waiting to be explored. The multiverse is an endless ocean of possibilities waiting to be explored.
Identify reference frames. Identify reference frames. Use Lorentz transformations. Use Lorentz transformations. Calculate time dilation. Calculate time dilation. Apply velocity addition. Apply velocity addition. Use energy-momentum relation. Use energy-momentum relation. Check spacetime invariance. Check spacetime invariance. Use 4 vectors. Use 4 vectors. Calculate proper time. Calculate proper time. Verify causality. Verify causality. Use Minkowski diagrams. Use Minkowski diagrams.
Gravity warps space like a heavy ball on a trampoline. Gravity warps space like a heavy ball on a trampoline. Massive stars create ripples when they collide like stones in a pond. Massive stars create ripples when they collide like stones in a pond. Massive objects stretch and compress space, sending out waves. Massive objects stretch and compress space, sending out waves. Gravitational waves are whispers of the cosmos carrying secrets. Gravitational waves are whispers of the cosmos carrying secrets. Massive collisions disturb space-time, sending out detectable waves. Massive collisions disturb space-time, sending out detectable waves. Gravity distorts space like heavy objects on a rubber sheet. Gravity distorts space like heavy objects on a rubber sheet. Cosmic events create gravitational waves like ripples on water. Cosmic events create gravitational waves like ripples on water. The universe's fabric vibrates with energy from massive collisions. The universe's fabric vibrates with energy from massive collisions.
String theory connects everything in the universe. String theory connects everything in the universe. It suggests tiny vibrating strings make up all matter and energy. It suggests tiny vibrating strings make up all matter and energy. These strings are too small to see, but they're everywhere. These strings are too small to see, but they're everywhere. String theory tries to unify all the laws of physics. String theory tries to unify all the laws of physics. It proposes multiple dimensions beyond the three we see. It proposes multiple dimensions beyond the three we see. These extra dimensions are hidden, making them invisible to us. These extra dimensions are hidden, making them invisible to us. String theory predicts particles like gravitons and photons. String theory predicts particles like gravitons and photons. It suggests black holes could be portals to other universes. It suggests black holes could be portals to other universes. The math behind string theory is complex but has led to breakthroughs. The math behind string theory is complex but has led to breakthroughs. String theory continues to inspire research and debate. String theory continues to inspire research and debate.
Science informs policy decisions that impact our lives. Science informs policy decisions that impact our lives. Understanding scientific concepts helps us make informed choices. Understanding scientific concepts helps us make informed choices. Access to accurate scientific information saves lives and prevents harm. Access to accurate scientific information saves lives and prevents harm. Scientific literacy is essential for civic engagement and participation. Scientific literacy is essential for civic engagement and participation. Science education fosters creativity, innovation, and economic growth. Science education fosters creativity, innovation, and economic growth. The public has a right to know about scientific discoveries and breakthroughs. The public has a right to know about scientific discoveries and breakthroughs.
Classical physics is like a predictable train schedule. Classical physics is like a predictable train schedule. Quantum physics is like a mysterious, never-ending puzzle. Quantum physics is like a mysterious never-ending puzzle. In classical physics, objects have definite positions and velocities. In classical physics, objects have definite positions and velocities.
But in quantum physics, particles can be anywhere until observed. But in quantum physics, particles can be anywhere until observed.
Classical physics relies on determinism, not randomness. Classical physics relies on determinism, not randomness. Quantum physics is all about probability and uncertainty. Quantum physics is all about probability and uncertainty. The Heisenberg uncertainty principle shows us the limits of knowledge. The Heisenberg uncertainty principle shows us the limits of knowledge. In classical physics, time flows like a straight line. In classical physics, time flows like a straight line. Schrödinger's cat illustrates the strange implications of superposition. Schrödinger's cat illustrates the strange implications of superposition.
Quantum computers use qubits to process information. Quantum computers use qubits to process information. Qubits can exist in multiple states at the same time. Qubits can exist in multiple states at the same time. Superposition is a key feature of quantum computing. Superposition is a key feature of quantum computing. Entanglement helps with data transfer and processing. Entanglement helps with data transfer and processing. Quantum computers are designed for complex calculations. Quantum computers are designed for complex calculations. Classical computers use bits while qubits are used in quantum computers. Classical computers use bits while qubits are used in quantum computers. Quantum gates manipulate the state of qubits to perform operations. Quantum gates manipulate the state of qubits to perform operations. Error correction is crucial when working with quantum computers. Error correction is crucial when working with quantum computers. Quantum algorithms can solve problems that are hard for classical computers. Quantum algorithms can solve problems that are hard for classical computers.
Spinors describe particle spin in quantum mechanics. Spinors describe particle spin in quantum mechanics. Pauli matrices represent spinor transformations efficiently. Pauli matrices represent spinor transformations efficiently. Spinors are key to describing particle properties in quantum mechanics. Spinors are key to describing particle properties in quantum mechanics. They are three-dimensional objects in complex space. They are three-dimensional objects in complex space. Spinors generalize vectors. Spinors generalize vectors. Spinor operations like multiplication and conjugation have specific rules. Spinor operations like multiplication and conjugation have specific rules.
In quantum, computing spinors encode and manipulate qubits. In quantum, computing spinors encode and manipulate qubits.
Understanding spinors is crucial for quantum field theory and particle physics. Understanding spinors is crucial for quantum field theory and particle physics.
Spinors are expressed as two-component vectors. Spinors are expressed as two-component vectors. Spinor space dimensionality is set by its Lorentz group representation. Spinor space dimensionality is set by its Lorentz group representation. Clifford algebra forms the foundation for spinor calculations. Clifford algebra forms the foundation for spinor calculations. Spinors are sections of complex line bundles over manifolds. Spinors are sections of complex line bundles over manifolds. Intrinsic spin is an inherent property of particles. Intrinsic spin is an inherent property of particles. The Weyl equation describes massless fermions left or right-handed. The Weyl equation describes massless fermions left or right-handed. A spinor can be a bispinor made up of two Weyl spinors. A spinor can be a bispinor made up of two Weyl spinors. Majorana spinors are their own antiparticles. Majorana spinors are their own antiparticles. Spinors are crucial for understanding fundamental particles in QFT. Spinors are crucial for understanding fundamental particles in QFT.
The astronaut is moving at high speed. The astronaut is moving at high speed. Time dilation occurs due to this motion. Time dilation occurs due to this motion. The twin on Earth remains stationary. The twin on Earth remains stationary. Each twin has a valid reference frame. Each twin has a valid reference frame. Astronaut experiences time more slowly than her sibling. Astronaut experiences time more slowly than her sibling. The astronaut's speed is constant and uniform. The astronaut's speed is constant and uniform. Proper time is measured in each inertial frame. Proper time is measured in each inertial frame. This acceleration affects the twin paradox outcome. This acceleration affects the twin paradox outcome. Their clocks started synchronized as expected. Their clocks started synchronized as expected. Twin aging results from distinct experiences of time flow. Twin aging results from distinct experiences of time flow.
I stay on Earth. I stay on Earth. You leave Earth with high speed. You leave Earth with high speed. Your clock runs slower than mine. Your clock runs slower than mine. Time dilation occurs because of your velocity. Time dilation occurs because of your velocity. You travel for a certain period. You travel for a certain period. Now you're returning to Earth. Now you're returning to Earth. Your velocity decreases to zero. Your velocity decreases to zero. The time difference is now apparent. The time difference is now apparent. I've aged more than you have. I've aged more than you have. This confirms the twin paradox theory. This confirms the twin paradox theory.
The harmonic oscillator is a key system in quantum mechanics. The harmonic oscillator is a key system in quantum mechanics. Its potential energy is proportional to the square of its displacement. Its potential energy is proportional to the square of its displacement. The force acting on it is proportional to displacement. The force acting on it is proportional to displacement. Its ground state has zero-point energy. Its ground state has zero-point energy. Excited states have quantized energy differences. Excited states have quantized energy differences. Solving Schrödinger's equation gives the allowed energies. Solving Schrödinger's equation gives the allowed energies. Energy levels are equally spaced in an arithmetic progression. Energy levels are equally spaced in an arithmetic progression. The system exhibits quantum coherence and entanglement. The system exhibits quantum coherence and entanglement. Quantum fluctuations in position show zero-point energy. Quantum fluctuations in position show zero-point energy.
Harmonic oscillators describe particle motion in potential wells. Harmonic oscillators describe particle motion in potential wells. Schrödinger's equation solves for wave functions of oscillators. Schrödinger's equation solves for wave functions of oscillators. These systems are linked to particles in quantum field theory. These systems are linked to particles in quantum field theory.
Harmonic oscillators are key in particle physics, like the Higgs boson. Harmonic oscillators are key in particle physics, like the Higgs boson.
Quantum fields are represented as harmonic oscillator modes. Quantum fields are represented as harmonic oscillator modes. Energy levels of oscillators correspond to particle masses. Energy levels of oscillators correspond to particle masses.
They share similarities with quantum chromodynamics. They They share similarities with quantum chromodynamics.
Oscillators model particle interactions in high-energy collisions. Oscillators model particle interactions in high-energy collisions. Their solutions serve as building blocks for complex systems. Their solutions serve as building blocks for complex systems. Harmonic oscillators describe particle behavior in accelerators. Harmonic oscillators describe particle behavior in accelerators.
Energy comes in discrete packets. Energy comes in discrete packets. Quantum mechanics shows us particles have a grainy nature. Quantum mechanics shows us particles have a grainy nature. Some properties can only be measured at specific values. Some properties can only be measured at specific values. Things don't exist until they're observed or interacted with. Things don't exist until they're observed or interacted with. The universe is made of tiny, indistinguishable chunks. The universe is made of tiny, indistinguishable chunks. Physical quantities have minimum possible amounts. Physical quantities have minimum possible amounts. In some cases, measurements are limited to exact values. In some cases, measurements are limited to exact values. The physical world is quantized into distinct states. The physical world is quantized into distinct states. All energies come in discrete packets called quanta. All energies come in discrete packets called quanta.
We start with a classical system with defined positions and momenta. We start with a classical system with defined positions and momenta. The goal is to apply quantum mechanics to this classical system. The goal is to apply quantum mechanics to this classical system. First, we identify the key variables describing the system's behavior. First, we identify the key variables describing the system's behavior. These variables are linked to operators in quantum mechanics. These variables are linked to operators in quantum mechanics. Classical variables are replaced by their operator representations. Classical variables are replaced by their operator representations. The equations of motion are used to derive the system's Hamiltonian. The equations of motion are used to derive the system's Hamiltonian. The Hamiltonian constructs a wave function for the quantum state. The Hamiltonian constructs a wave function for the quantum state. Schrödinger's equation evolves the wave function over time. Schrödinger's equation evolves the wave function over time. This evolution gives energy I in values and eigenstates. This evolution gives energy I in values and eigenstates. These results reveal the quantum properties of the classical system. These results reveal the quantum properties of the classical system.
The ground state represents the minimum energy configuration. The ground state represents the minimum energy configuration. It's a crucial concept for understanding thermodynamic equilibrium. It's a crucial concept for understanding thermodynamic equilibrium. The ground state provides a reference point for other quantum states. The ground state provides a reference point for other quantum states. Quantum systems always prefer to be in their ground state. Quantum systems always prefer to be in their ground state. The ground state is essential for calculating the system's properties. The ground state is essential for calculating the system's properties. It serves as a benchmark for comparing energy levels. It serves as a benchmark for comparing energy levels. Understanding the ground state helps us predict quantum behavior. Understanding the ground state helps us predict quantum behavior. Ground states are typically stable and well-defined. Ground states are typically stable and well-defined. The ground state is often associated with zero-point fluctuations. The ground state is often associated with zero-point fluctuations. Analyzing the ground state reveals important information about interactions. Analyzing the ground state reveals important information about interactions.
We're making progress on harnessing nuclear fusion. We're making progress on harnessing nuclear fusion. Nuclear fusion holds great promise for a clean energy future. Nuclear fusion holds great promise for a clean energy future. Scientists are working tirelessly to achieve this breakthrough. Scientists are working tirelessly to achieve this breakthrough. The potential for fusion is vast and exciting. The potential for fusion is vast and exciting. Researchers are optimistic about the feasibility of fusion power. Researchers are optimistic about the feasibility of fusion power. We need nuclear fusion to meet our growing energy demands. We need nuclear fusion to meet our growing energy demands. Private companies are investing heavily in fusion research. Private companies are investing heavily in fusion research. Nuclear fusion has the potential to solve global energy problems. Nuclear fusion has the potential to solve global energy problems. New technologies are being developed to make fusion more efficient. New technologies are being developed to make fusion more efficient. The quest for nuclear fusion is a long-term investment in our future. The quest for nuclear fusion is a long-term investment in our future.
Lasers emit intense beams of light. Lasers emit intense beams of light. These beams can be precisely controlled in direction. These beams can be precisely controlled in direction. Lasers have many practical uses such as cutting materials. Lasers have many practical uses such as cutting materials. They also enable precise measurements and analysis. They also enable precise measurements and analysis. Laser technology has improved medical procedures significantly. Laser technology has improved medical procedures significantly. In communications, lasers help transmit data over long distances. In communications, lasers help transmit data over long distances. Lasers are used in manufacturing to create microchips. Lasers are used in manufacturing to create microchips. Their high precision makes them ideal for scientific research. Their high precision makes them ideal for scientific research. Laser-based systems can accurately measure speeds and distances. Laser-based systems can accurately measure speeds and distances.
Identify particles. Identify particles. Use the standard model. Use the standard model.
Check conservation laws. Check conservation laws.
Draw Feynman diagrams. Draw Feynman diagrams. Calculate cross-sections. Calculate cross-sections. Apply QED rules. Apply QED rules. Use the quark model. Use the quark model. Check symmetry breaking. Check symmetry breaking. Use experimental data. Use experimental data. Verify with theory. Verify with theory.
Dark matter is needed for flat galaxy rotation curves. Dark matter is needed for flat galaxy rotation curves. Galaxies rotate faster than expected without dark matter. Galaxies rotate faster than expected without dark matter. Dark matter explains observed galaxy motions. Dark matter explains observed galaxy motions. Most galaxies contain large amounts of invisible dark matter. Most galaxies contain large amounts of invisible dark matter. Dark matter shapes galaxy clusters. Dark matter shapes galaxy clusters. Galaxy clusters wouldn't hold together without dark matter. Galaxy clusters wouldn't hold together without dark matter.
Galaxy velocity distributions require dark matter. Galaxy velocity distributions require dark matter.
Dark matter dominates the mass of large galaxies. Dark matter dominates the mass of large galaxies. Rotation curves a line with a significant dark matter component. Rotation curves a line with a significant dark matter component. Star and gas motion in galaxies depend on dark matter density. Star and gas motion in galaxies depend on dark matter density.
The Hubble constant measures the universe's expansion rate. The Hubble constant measures the universe's expansion rate. It helps determine the universe's age. It helps determine the universe's age. Determining it requires measuring galaxy velocities. Determining it requires measuring galaxy velocities. Cosmologists use it to inform models of the universe's evolution. Cosmologists use it to inform models of the universe's evolution. Accurate measurement of the Hubble constant is a major challenge. Accurate measurement of the Hubble constant is a major challenge. It reveals dark energy's role in cosmic expansion. It reveals dark energy's role in cosmic expansion. Various methods are used to estimate the Hubble constant precisely. Various methods are used to estimate the Hubble constant precisely. It aids in understanding galaxy formation and evolution. It aids in understanding galaxy formation and evolution.
Gravitational waves exist and were detected. Gravitational waves exist and were detected. They are ripples in the fabric of space-time. They are ripples in the fabric of space-time. These waves travel at the speed of light. These waves travel at the speed of light. They were predicted by Albert Einstein's theory of general relativity. They were predicted by Albert Einstein's theory of general relativity. Gravitational waves carry information about massive cosmic events. Gravitational waves carry information about massive cosmic events. Detecting them requires incredibly sensitive instruments. Detecting them requires incredibly sensitive instruments. Scientists use lasers to detect these tiny ripples. Scientists use lasers to detect these tiny ripples. They are a new way of observing the universe. They are a new way of observing the universe. Gravitational waves can reveal secrets about black holes and neutron stars. Gravitational waves can reveal secrets about black holes and neutron stars. Their discovery has opened up a new field of astronomy. Their discovery has opened up a new field of astronomy.
The Higgs boson is a fundamental particle. The Higgs boson is a fundamental particle.
It helps explain how other particles acquire mass. It helps explain how other particles acquire mass. The Higgs field permeates all of space and time. The Higgs field permeates all of space and time. Particles interact with the Higgs field to gain mass. Particles interact with the Higgs field to gain mass.
The Standard Model predicts the existence of the Higgs boson. The Standard Model predicts the existence of the Higgs boson. The Higgs boson is a scalar boson with zero spin. The Higgs boson is a scalar boson with zero spin.
Its discovery confirmed the completeness of the Standard Model. Its discovery confirmed the completeness of the Standard Model.
Matter falling into a black hole heats up. Matter falling into a black hole heats up. Black holes have no surface tension to contain them. Black holes have no surface tension to contain them. Energy is released as particles escape from the event horizon. Energy is released as particles escape from the event horizon. Quantum effects make black holes slowly lose mass. Quantum effects make black holes slowly lose mass. As black holes shrink, their temperature increases. As black holes shrink, their temperature increases. Hawking radiation is a theoretical prediction of quantum mechanics. Hawking radiation is a theoretical prediction of quantum mechanics. Energy can be extracted from black holes via Hawking radiation. Energy can be extracted from black holes via Hawking radiation. Black hole evaporation occurs when the mass is reduced to zero. Black hole evaporation occurs when the mass is reduced to zero. The surface gravity determines the temperature of a black hole. The surface gravity determines the temperature of a black hole. General relativity and quantum mechanics agree on Hawking radiation. General relativity and quantum mechanics agree on Hawking radiation. The strong nuclear force binds quarks in protons and neutrons. The strong nuclear force binds quarks in protons and neutrons. It keeps atomic nuclei stable despite charge repulsion. It keeps atomic nuclei stable despite charge repulsion. Quarks are held by gluons, a process that creates mass. Quarks are held by gluons, a process that creates mass. The force prevents electrons from getting too close to protons. The force prevents electrons from getting too close to protons. Without it, nuclei would decay into quarks and leptons. Without it, nuclei would decay into quarks and leptons. Binding energy from the strong force keeps nuclei intact. Binding energy from the strong force keeps nuclei intact. Gluons mediate the strong force between hadrons. Gluons mediate the strong force between hadrons. The force explains why atomic nuclei are seen as single units. The force explains why atomic nuclei are seen as single units. Nuclear binding energy strength depends on proton count. Nuclear binding energy strength depends on proton count.
They can transform industries with their powerful capabilities. They can transform industries with their powerful capabilities. These machines use unique properties of matter and energy. These machines use unique properties of matter and energy. Quantum computers solve problems beyond traditional computers. Quantum computers solve problems beyond traditional computers. This tech promises to tackle complex scientific challenges. This tech promises to tackle complex scientific challenges. Quantum computing could revolutionize fields like medicine and finance. Quantum computing could revolutionize fields like medicine and finance. Its operations are grounded in quantum mechanics principles. Its operations are grounded in quantum mechanics principles. Researchers are exploring real-world applications for quantum computers. Researchers are exploring real-world applications for quantum computers. Quantum computing is a leap forward in power and scalability. Quantum computing is a leap forward in power and scalability. By exploiting subatomic behaviors, we can create more efficient computers. By exploiting subatomic behaviors, we can create more efficient computers.
Matter makes up everything around us. Matter makes up everything around us. Antimatter is like matter, but with opposite charges. Antimatter is like matter, but with opposite charges. When matter meets antimatter, they annihilate in a burst of energy. When matter meets antimatter, they annihilate in a burst of energy. The universe has more matter than antimatter, explaining our existence. The universe has more matter than antimatter, explaining our existence. The difference between them is a small variation in atomic structure. The difference between them is a small variation in atomic structure. Antimatter has the same mass as matter but behaves oppositely. Antimatter has the same mass as matter but behaves oppositely. Scientists are creating antimatter in labs to study its properties. Scientists are creating antimatter in labs to study its properties.
Mass warps spacetime. Mass warps spacetime. Gravity is a curvature effect. Gravity is a curvature effect. Spacetime is not flat everywhere. Spacetime is not flat everywhere. Curvature affects the path of objects. Curvature affects the path of objects. The stronger the mass, the greater the curvature. The stronger the mass, the greater the curvature. Energy also warps spacetime. Energy also warps spacetime. Geodesics follow curved trajectories. Geodesics follow curved trajectories. Time dilation occurs near massive objects. Time dilation occurs near massive objects. Spacetime curvature varies with location. Spacetime curvature varies with location. Matter distorts the fabric of spacetime. Matter distorts the fabric of spacetime.
Information is encoded on surfaces, not volumes. Information is encoded on surfaces, not volumes. Everything in space reflects on its boundary. Everything in space reflects on its boundary. The holographic principle changes our view of spacetime. The holographic principle changes our view of spacetime. The information in a region is equivalent to what's on its surface. The information in a region is equivalent to what's on its surface. Space and time are emergent, not fundamental. Space and time are emergent, not fundamental. Quantum gravity can be described through holographic codes. Quantum gravity can be described through holographic codes. Black holes are holographic information containers. Black holes are holographic information containers. Everything is connected through holographic relationships. Everything is connected through holographic relationships.
The information paradox persists. The information paradox persists. Black holes have a finite temperature. Black holes have a finite temperature. Holography resolves the paradox. Holography resolves the paradox. The entropy of black holes increases with mass. The entropy of black holes increases with mass. Gravitational information is encoded on surfaces. Gravitational information is encoded on surfaces.
Thermodynamics governs black hole behavior. Thermodynamics governs black hole behavior.
The holographic principle has many implications. The holographic principle has many implications. Black holes are in a thermal state. Black holes are in a thermal state. The first law of thermodynamics applies to black holes. The first law of thermodynamics applies to black holes. Holography is consistent with general relativity. Holography is consistent with general relativity.
Quantum particles can become entangled. Quantum particles can become entangled. Entangled particles can affect each other's properties. Entangled particles can affect each other's properties. The state of one particle is connected to the state of another. The state of one particle is connected to the state of another.
Measuring one particle instantly affects the other. Measuring one particle instantly affects the other.
This connection happens even if they're separated by huge distances. This connection happens even if they're separated by huge distances. Entangled particles are not independent but rather correlated. Entangled particles are not independent but rather correlated. Their properties are linked in a way that transcends space and time. Their properties are linked in a way that transcends space and time.
Gauge theories describe forces as fields. Gauge theories describe forces as fields. The Standard Model explains particle interactions via gauge forces. The Standard Model explains particle interactions via gauge forces.
Yang-Mills theory applies to non-abelian forces like QCD. Yang-Mills theory applies to non-abelian forces like QCD.
The Higgs mechanism is a type of spontaneous symmetry breaking. The Higgs mechanism is a type of spontaneous symmetry breaking.
Gauge fields mediate interactions, and their excitations are vector bosons. Gauge fields mediate interactions, and their excitations are vector bosons.
Electroweak unification combines electromagnetic and weak forces. Electroweak unification combines electromagnetic and weak forces. Gauge invariance ensures interactions are frame independent. Gauge invariance ensures interactions are frame independent.
Quantum decoherence erases superposition. Quantum decoherence erases superposition. It causes wave function collapse via environment interactions. It causes wave function collapse via environment interactions. Decoherence introduces noise-making states classical-like. Decoherence introduces noise-making states classical-like. Phase coherence is lost, preventing quantum effects. Phase coherence is lost, preventing quantum effects. The environment drives the quantum to classical transition. The environment drives the quantum to classical transition. It helps resolve the measurement problem in quantum mechanics. It helps resolve the measurement problem in quantum mechanics. This process limits quantum mechanics' observable effects. This process limits quantum mechanics' observable effects. Decoherence impacts quantum computing and cryptography. Decoherence impacts quantum computing and cryptography. Understanding decoherence is key to quantum technologies. Understanding decoherence is key to quantum technologies.
Define the action. Define the action. Sum over all possible paths. Sum over all possible paths.
Write the path integral with the Lagrangian. Write the path integral with the Lagrangian. Discretize spacetime. Discretize spacetime.
Find the classical path by minimizing the action. Find the classical path by minimizing the action. Use perturbation theory for small deviations. Use perturbation theory for small deviations. Apply boundary conditions to restrict paths. Apply boundary conditions to restrict paths. Use symmetries to simplify the integral. Use symmetries to simplify the integral. Apply Wick rotation if needed. Apply Wick rotation if needed. Evaluate using saddle point or Feynman diagrams. Evaluate using saddle point or Feynman diagrams.
Renormalization is key in quantum field theory. Renormalization is key in quantum field theory. The renormalization group explains how systems change across scales. The renormalization group explains how systems change across scales. It predicts high-energy particle interactions. It predicts high-energy particle interactions. Renormalization ensures consistent predictions. Renormalization ensures consistent predictions. Renormalization, group flow diagrams track parameter, evolution. Renormalization, group flow diagrams track parameter, evolution. It helps analyze phase transitions and critical points. It helps analyze phase transitions and critical points. Universal properties emerge through the RG. Universal properties emerge through the RG. It predicts critical exponents and scaling laws. It predicts critical exponents and scaling laws. Renormalization is key in quantum field theory. Renormalization is key in quantum field theory. The renormalization group aids in studying complex, many-body systems. The renormalization group aids in studying complex, many-body systems. Loop quantum gravity unifies quantum mechanics and relativity. Loop quantum gravity unifies quantum mechanics and relativity. It suggests space is quantized at the Planck scale. It suggests space is quantized at the Planck scale. The theory eliminates singularities in general relativity. The theory eliminates singularities in general relativity. Spacetime has a discrete granular structure. Spacetime has a discrete granular structure. Loop quantum gravity explains aspects of black hole physics. Loop quantum gravity explains aspects of black hole physics. It offers new insights into space and time. It offers new insights into space and time. Research advances our understanding of gravity. Research advances our understanding of gravity. Its mathematical foundations continue to evolve. Its mathematical foundations continue to evolve. The theory is background independent. The theory is background independent. It provides a path toward quantum gravity. It provides a path toward quantum gravity.
Cosmic inflation was a rapid early expansion. Cosmic inflation was a rapid early expansion. It smoothed irregularities and flattened the universe. It smoothed irregularities and flattened the universe. The universe expanded exponentially during inflation. The universe expanded exponentially during inflation. The universe was extremely hot and dense then. The universe was extremely hot and dense then. Inflation solved the horizon problem. Inflation solved the horizon problem. It followed the quantum gravity era. It followed the quantum gravity era. Quantum fluctuations shaped the universe's structure. Quantum fluctuations shaped the universe's structure. Inflation explains cosmic homogeneity. Inflation explains cosmic homogeneity.
Black holes emit radiation. Black holes emit radiation. Hawking radiation is a theoretical prediction. Hawking radiation is a theoretical prediction. The information paradox remains unresolved. The information paradox remains unresolved. Black hole evaporation occurs at the event horizon. Black hole evaporation occurs at the event horizon. Temperature decreases as mass increases in black holes. Temperature decreases as mass increases in black holes. Radiation causes entropy to increase within a black hole. Radiation causes entropy to increase within a black hole. Quantum effects dominate near singularity points. Quantum effects dominate near singularity points. Black holes behave like perfect thermal systems. Black holes behave like perfect thermal systems. Thermodynamic principles apply universally in the universe. Thermodynamic principles apply universally in the universe. The no-boundary proposal resolves singularities. The no-boundary proposal resolves singularities.
The Unruh effect is real and observable. The Unruh effect is real and observable. Accelerated observers experience a thermal background. Accelerated observers experience a thermal background.
This effect has significant implications for inertial frames. This effect has significant implications for inertial frames. The Unruh effect is a fundamental consequence of special relativity. The Unruh effect is a fundamental consequence of special relativity. It demonstrates the importance of observer reference frames. It demonstrates the importance of observer reference frames. Accelerated observers have a unique thermal perspective. Accelerated observers have a unique thermal perspective. This phenomenon challenges classical notions of space and time. This phenomenon challenges classical notions of space and time.
The Unruh effect is a key aspect of accelerated frame physics. The Unruh effect is a key aspect of accelerated frame physics.
Its implications are far-reaching in the study of relativity. Its implications are far-reaching in the study of relativity.
The information paradox remains unsolved. The information paradox remains unsolved. Hawking radiation has thermodynamic significance. Hawking radiation has thermodynamic significance. Event horizons are one-way membranes. Event horizons are one-way membranes. Quantum mechanics governs black hole behavior. Quantum mechanics governs black hole behavior. Black holes have an inherent temperature. Black holes have an inherent temperature.
Information cannot escape a black hole. Information cannot escape a black hole.
Singularity theorems confirm black hole existence. Singularity theorems confirm black hole existence. Black hole entropy is proportional to surface area. Black hole entropy is proportional to surface area. Quantum gravity resolves the information paradox. Quantum gravity resolves the information paradox.
Schrödinger's cat is a thought experiment. Schrödinger's cat is a thought experiment. It helps us understand quantum superposition. It helps us understand quantum superposition. The cat can be both alive and dead at the same time. The cat can be both alive and dead at the same time. Superposition means existing in multiple states simultaneously. Superposition means existing in multiple states simultaneously. Schrödinger's cat is a famous example of quantum entanglement. Schrödinger's cat is a famous example of quantum entanglement. The cat's fate is connected to the decay of a radioactive atom. The cat's fate is connected to the decay of a radioactive atom. When observed, the cat collapses into one definite state. When observed, the cat collapses into one definite state. This phenomenon demonstrates the weirdness of quantum mechanics. This phenomenon demonstrates the weirdness of quantum mechanics.
Superposition enables parallel processing in quantum systems. Superposition enables parallel processing in quantum systems. It allows quantum computers to explore all solutions simultaneously. It allows quantum computers to explore all solutions simultaneously. Superposition expands the Hilbert space for qubits. Superposition expands the Hilbert space for qubits. It is essential for quantum information processing and storage. It is essential for quantum information processing and storage. Superposition lets qubits represent many possibilities at once. Superposition lets qubits represent many possibilities at once. It enables the encoding of multiple bits in a single qubit. It enables the encoding of multiple bits in a single qubit. Superposition is key to quantum parallelism and speedup. Superposition is key to quantum parallelism and speedup. Superposition is required for quantum entanglement. Superposition is required for quantum entanglement. It enables the creation of complex quantum states and behaviors. It enables the creation of complex quantum states and behaviors.
We might be alone in the universe. We might be alone in the universe. Intelligent life elsewhere may be rare. Intelligent life elsewhere may be rare. There may be reasons we haven't detected any signals. There may be reasons we haven't detected any signals. Advanced civilizations could be too distant to detect. Advanced civilizations could be too distant to detect. Other civilizations may not be communicating with us. Other civilizations may not be communicating with us. We might detect a signal from another civilization soon. We might detect a signal from another civilization soon. The Fermi paradox is an unresolved mystery. The Fermi paradox is an unresolved mystery. The great filter could explain why we don't make contact. The great filter could explain why we don't make contact. The possibility of extraterrestrial life warrants further investigation. The possibility of extraterrestrial life warrants further investigation.
The kinetic theory of gases explains how molecules behave. The kinetic theory of gases explains how molecules behave. Gas molecules move randomly due to thermal energy. Gas molecules move randomly due to thermal energy.
Collisions between molecules transfer energy and momentum. Collisions between molecules transfer energy and momentum.
Pressure in a gas is caused by molecular collisions. Pressure in a gas is caused by molecular collisions. Ideal gases obey the ideal gas law under specified conditions. Ideal gases obey the ideal gas law under specified conditions. The Maxwell-Boltzmann distribution describes molecular velocities. The Maxwell-Boltzmann distribution describes molecular velocities. Brownian motion illustrates the random nature of molecular motion. Brownian motion illustrates the random nature of molecular motion.
Nuclear fusion is the future of clean energy. Nuclear fusion is the future of clean energy. Fusion power could revolutionize the way we generate electricity. Fusion power could revolutionize the way we generate electricity. This technology has the potential to replace fossil fuels entirely. This technology has the potential to replace fossil fuels entirely. Clean, sustainable energy from nuclear fusion is within reach. Clean, sustainable energy from nuclear fusion is within reach. Nuclear fusion can provide virtually limitless energy for centuries to come. Nuclear fusion can provide virtually limitless energy for centuries to come. Harnessing fusion power will drastically reduce greenhouse gas emissions. Harnessing fusion power will drastically reduce greenhouse gas emissions. The benefits of nuclear fusion far outweigh its complexity. The benefits of nuclear fusion far outweigh its complexity. Nuclear fusion is a game changer for addressing climate change. Nuclear fusion is a game changer for addressing climate change.
Time dilation occurs at high speeds. Time dilation occurs at high speeds. Astronauts experience slower time compared to Earth observers. Astronauts experience slower time compared to Earth observers. Length contraction occurs for objects moving at high speeds. Length contraction occurs for objects moving at high speeds. The Lorentz factor links space and time coordinates between frames. The Lorentz factor links space and time coordinates between frames. The speed of light is constant for all observers. The speed of light is constant for all observers. Mass remains unchanged, but energy and momentum transform. Mass remains unchanged, but energy and momentum transform. Relativistic velocity addition follows Lorentz transformation. Relativistic velocity addition follows Lorentz transformation. Special relativity relies on Lorentz transformation equations. Special relativity relies on Lorentz transformation equations.
The Higgs field gives particles mass. The Higgs field gives particles mass. It explains mass acquisition. It explains mass acquisition. The Higgs mechanism generates mass. The Higgs mechanism generates mass. The Higgs field interacts with fermions and bosons. The Higgs field interacts with fermions and bosons. Mass is generated for particles without direct Higgs coupling. Mass is generated for particles without direct Higgs coupling. The Higgs boson confirms the mechanism. The Higgs boson confirms the mechanism. Its discovery was a key milestone. Its discovery was a key milestone. The Higgs field breaks electroweak symmetry. The Higgs field breaks electroweak symmetry. This separates electromagnetic and weak forces. This separates electromagnetic and weak forces. The Higgs mechanism deepens particle physics understanding. The Higgs mechanism deepens particle physics understanding.
String theory can unify all fundamental forces. String theory can unify all fundamental forces. Gravity is a vibration of strings. Gravity is a vibration of strings. Extra dimensions exist beyond R3. Extra dimensions exist beyond R3. Superstrings have 6 or 10 dimensions. Superstrings have 6 or 10 dimensions. Theories need unification to be complete. Theories need unification to be complete. Mathematics describes string theory perfectly. Mathematics describes string theory perfectly. All forces are manifestations of strings. All forces are manifestations of strings. Strings have different vibrational modes. Strings have different vibrational modes. Unifying forces requires new perspectives. Unifying forces requires new perspectives.
Antimatter has opposite properties to matter. Antimatter has opposite properties to matter. Antiprotons and antineutrons are antimatter counterparts. Antiprotons and antineutrons are antimatter counterparts. The universe began with matter and antimatter after the Big Bang. The universe began with matter and antimatter after the Big Bang. When they meet, matter and antimatter annihilate. When they meet, matter and antimatter annihilate. This creates energy seen in stars and galaxies. This creates energy seen in stars and galaxies. Balance between matter and antimatter is key to the universe. Balance between matter and antimatter is key to the universe. Researchers are exploring antimatter's energy potential. Researchers are exploring antimatter's energy potential. Dark matter may be made of antimatter particles. Dark matter may be made of antimatter particles. Particle accelerators create and study antimatter. Particle accelerators create and study antimatter. Antimatter reveals fundamental forces of the universe. Antimatter reveals fundamental forces of the universe.
Black holes have an event horizon, the point of no return. Black holes have an event horizon, the point of no return. At the event horizon, gravity becomes infinitely strong. At the event horizon, gravity becomes infinitely strong. Anything crossing the event horizon is trapped by the black hole's gravity. Anything crossing the event horizon is trapped by the black hole's gravity. The event horizon surrounds the singularity at the black hole's center. The event horizon surrounds the singularity at the black hole's center. Light cannot escape once it crosses the event horizon. Light cannot escape once it crosses the event horizon. The event horizon is a mathematical boundary, not a physical surface. The event horizon is a mathematical boundary, not a physical surface. Understanding the event horizon helped confirm Einstein's theory of relativity. Understanding the event horizon helped confirm Einstein's theory of relativity. The event horizon marks the boundary beyond which matter and energy are lost. The event horizon marks the boundary beyond which matter and energy are lost.
Hilbert space is used in quantum mechanics. Hilbert space is used in quantum mechanics. It is a vector space with an inner product. It is a vector space with an inner product. Quantum states are vectors in Hilbert space. Quantum states are vectors in Hilbert space. Operators act on Hilbert space in quantum theory. Operators act on Hilbert space in quantum theory. Hilbert space can be finite or infinite. Hilbert space can be finite or infinite. Orthogonality is important in Hilbert space. Orthogonality is important in Hilbert space. The inner product defines probabilities in quantum mechanics. The inner product defines probabilities in quantum mechanics. Hilbert space helps describe quantum systems. Hilbert space helps describe quantum systems. It is crucial for quantum computing and field theory. It is crucial for quantum computing and field theory. The dimension of Hilbert space varies by system. The dimension of Hilbert space varies by system.
Vacuum energy contributes to the universe's mass-energy budget. Vacuum energy contributes to the universe's mass-energy budget. The cosmological constant measures vacuum energy density. The cosmological constant measures vacuum energy density. Quantum fluctuations cause vacuum energy's positive value. Quantum fluctuations cause vacuum energy's positive value. Vacuum energy contributes to dark energy's acceleration. Vacuum energy contributes to dark energy's acceleration. Experimental evidence supports negative vacuum energy states. Experimental evidence supports negative vacuum energy states. Cosmic microwave background radiation suggests vacuum energy. Cosmic microwave background radiation suggests vacuum energy. Theoretical models predict vacuum energy's importance at higher energies. Theoretical models predict vacuum energy's importance at higher energies. Vacuum energy drives the observed acceleration in cosmic expansion. Vacuum energy drives the observed acceleration in cosmic expansion.